Hi, and welcome to the course Getting Started with vRealize Operations Manager. This course is being delivered by Scott Norris and Christopher Slater, the authors of Mastering vRealize Operations Manager by Pack Publishing. This course is to dive into the basics of vRealize Operations Manager, to get an understanding and a good solid foundation so we can move forward with more advanced learnings and get you underway to really using vRealize Operations Manager. This course is broken into a number of different sections. First off, which is the UI, where we'll take a look through all the different sections and areas within the vRealize Operations Manager UI, so we have a good understanding of where everything is, so we can quickly navigate around. Second is security, where we'll look at how we give users access to vRealize Operations Manager, so that we can connect to your local Active Directory, assign roles and groups and users to specific areas within vRealize Operations Manager. Next up, we'll have solutions. This is where metrics come from. So these are the endpoints that we want to configure, how to install, how to upgrade. We're going to then dive into badges to find out how they work, what they are, and understand the three major badges that vRealize Operations Manager gives back. Then we're going to have a look at policies. Policies are the heart of vROps. They are what tell it what to do, how to calculate its metrics, what metrics to collect, and what symptoms and alerts to have active. Then we're going to have a look at capacity management. Will show you the difference between demand and allocation versus consumed, what buffers are, project pipeline management, and just general all-round how to set up your capacity management within your system. Hi, and welcome to the section, the installation. In this section, we're going to take a look at deploying the appliance, the initial configuration of the vRealize Operations Manager appliance, and then connecting the vCenter endpoint. In the first video, we'll be looking at deploying the appliance. And this video is very simple. It's going to download the OVA and deploy the appliance through vCenter. Okay, once we have the appliance downloaded, now with vRealize Operations Manager, you can install it on a Windows machine, you can install it on a Linux machine, and there's the appliance. Now we highly recommend the appliance as there's less configuration required. You can cluster, you can scale it, it's nice, and it works. Once you download from vMware.com using your support account, or you can sign up and get the 60-day free trial, which will allow you to download it, we need to log into our vCenter. So here I'm going to log into the web client, and once we're logged into the web client, we want to choose the cluster. We want to deploy the OVF or OVA2. So I'll go to the cluster, I'll choose my lab here, and let's deploy a template. Now we want to choose the file, and in this case it will be software, VMware, and there's my vRealize Operations Manager appliance. Hit next, and that looks fine. Next, we accept the license agreements. We give it a name. Choose the data center. Now we choose our configuration. So this is based on the size. This is just a demo environment, so I'm going to do a small, but medium and large will depend on the sizing. So look at the documentation and choose size to go along with what you require to collect. So actually I might go extra small for this, which is 2 vCPUs and 8 gig of memory. And we see a large is 16 and 48. I want, so next. Now we choose our data store that we want it on. So I'll just do it on the vCenter data store here. We choose the network that we want it on. And this is where we have a couple of settings. So choose your time zone. For me, it's Australia, Canberra. I don't want IPv6, but I need to set the network properties. So these are what the node or that we're currently configuring is going to be. So my default gateway, my DNS, IP address for this machine, and the subnet mask. We hit next, and we review our information here, and then select power on after deployment because we want to get right into it, and we hit finish. That will go off and deploy the appliance, and you do that for as many nodes as you want to make part of the cluster. For this, we're just going to do a single node, and we wait till it's finished. In this video, we had a look at how to deploy the appliance. The next video, we'll look at initial configuration of that appliance. In the last video, we saw how to deploy vRealize Operations Manager node through the vCenter web client. This next video, we're going to take a look at the initial configuration, where we're going to have a look at the install options, the setup wizard, and then starting the cluster after that. For the initial configuration, we browse to the appliance that we've just deployed, and we'll get this getting started homepage. Now here we have three options. We can expanding an existing solution, which allows us to add additional nodes to an already existing cluster. We can do a new installation or do an express installation. So express installation sets most things up for you. You don't really configure anything. So I recommend doing a new installation for the very first node. So we click on that, and then we get the installation wizard. The getting started. It gives you a nice diagram of how to use it. We hit next. First we want to give the admin password. Like that. Hit next. Now this is where we will enter a certificate. So you would create your own CA sign certificate, or for this quick demo, we're just going to use the default self-signed. And then we give it master node name. So for this, I'd recommend not putting master in the name, because the master can change depending if you have failures. So I'd keep this nice and simple and meaningful with an increment. So this would be our first node. So in this instance, we'll do vROps 01 as an example. We give a NTP address. So for me, we add it in. We can see that's fine. It's been able to connect to that correctly. We go next, and then it's ready. We finish. It now moves into what is our admin UI. So to get to this, normally we would have the IP address or fully qualified domain name with /admin, and when we'd use our admin and the password we got to log into it. So this is where it will do the initial cluster configuration. So once you've got the first node in here and it's up and running, you can then add additional nodes to that before you actually start up the initial instance. You can add extra nodes afterwards if you want, but now we wait till it's ready. Cool. So we've got, there's our node name there, and we can see it's not running, it's offline, our build version, etc. So we could then go ahead and add additional nodes to this if we wanted to by using that expand existing solution option on the welcome page that we had initially if we wanted to spin up more nodes. But in this instance we don't want to. This is where it would also enable high availability if there was 2 or more. But please be note that high availability means that you will double your IOPS as well as you can only ever have one failure. So it's not, if you've got 6 nodes in your cluster, it can still only tolerate one failure. So for that instance, we go, right, I want to start vRealize Operations Manager. It'll make sure, are you sure you want to? Have you got all your nodes? So you go, yep. And now it's going to do the first initialization. Now it's going online, and since it has nothing to connect to, it should be fairly quick. Once the cluster goes online, we will get prompted with the login. It automatically redirects us, so we log in with our admin and the password we set during the wizard. And we're met with another wizard, which is our next lot of configuration. We can see there what it's going to do. We go next. We accept the ULA. We enter our product key. For now, I'll just go evaluation. We can join the customer experience program if you can. It's always good to join it. The feedback helps improve the product. And then we're ready. Finish. And now it's time to configure our solutions. In this video, we looked at the initial configuration after the deployment of vRealize Operations Manager. The next video, we're going to take a look at connecting the vCenter endpoint to start that data collection. In the previous video, we looked at how to set up the initial configuration of our vRealize Operations Manager cluster. In this video, we're going to have a look at connecting the vCenter endpoint, which is the inbuilt vCenter solution, which comes as part of vRealize Operations Manager. Now, when we first log in, after the initial configuration, we will get prompted directly with the solutions page. Here is where we want to set up our vCenter adapter or endpoint. We can see here that it is not configured, so we hit the old cog button up here. We'll give it a name. Give it something meaningful, and if you're having more than one vCenter that you're connecting to, obviously make sure you know which ones they are. In this case, I'll just do vCenter 01. Give a description. Now first we do the basic settings. So we want to give our vCenter server, so this is an IP address or a fully qualified domain name. So I'll do, we want a credential, so we won't have any credentials here, so we go new, credential name, give the login, and password. Okay. Now we can enable actions, so this means that vRealize Operations Manager can initiate actions to vMotion machines, or to turn them off, or to add CPU, depending on the type of actions that we allow it to do. And we'll click enable here. Now we can add alternate credentials for the actions, which is perfectly fine. In this case, it's not. I'm just going to use the same as the admin here, and if we don't put anything in there, that's what it uses. Want to test the connection? We get our cert from vCenter, and then do a test. Great, test was successful. Now in here, we can do some advanced settings. Now initially, I would say don't touch these. Everything in here, default, is perfectly fine. We can do a registration. So initially when you first connect, or do a register, now you can have multiple vRealize Operation Manager solutions connecting to the same vCenter. Now, but only one can be registered, meaning when we go to the web client, the badges will only show up from whichever one is registered to vCenter, but all of them can connect and grab the metrics. So in here we hit Save Settings. Because, as I was saying before, this has already got registered and there's going to be a conflict. You can override the existing registration if this is your new instance and your main one, or you click no. In this case, I'm going to go no. I just want the metrics out of it. And we close it. Now we can see that's now gone to collecting. This will soon say collection status of data receiving, which it is. Now, if we go to our environment, I should now be able to see my vCenter and all the machines. None of them will have badges or health or metrics yet. We'll have to wait for a few cycles till they're collecting, but it's now collecting. And that's it for the initial setup and configuration of vRealize Operations Manager. This was the last video of the section. In this video, we looked at setting up the vCenter endpoint or vCenter solution to start the data collection for us to be able to work from. In this section, we had a look at deploying the vROps appliance through the web client. We did the initial cluster configurations, and we set up our vCenter connection to start the data coming in. The next section is the UI and access control. Hi, and welcome to the section the UI of vRealize Operations Manager. In this section, we're going to have a look at the whole UI of vRealize Operations Manager. This includes the home page, the alert section, the environment section, the content section, and the administration section. All these different areas will show you what's in them, how to browse to it, where things are, so that you can quickly and easily locate what you're looking for. The first video, the home page. In this video, we're going to take a close look at vRealize Operations Manager homepage, have a look around, see how to change dashboards, and how to cycle dashboards if we want to send them on a loop, so we can put them on a display screen. First, we browse to our vRealize Operations Manager web portal, and we log in. Here, we'll log in with the local admin, which would be the first account that you would have to log into this after setting up. And the first page we see is our home page. Now, the home page contains all the dashboards. These are the dashboards that we're allowed to see, as well as the dashboards that we want to see. On the left-hand pane here, we can see our navigation. So, we've got our home, which we're on, our alerts, environment, content, and administration, and we can also see the same down here. Now, this top row here is something we can see no matter where we are in vRealize Operations Manager, and this navigation pane down here will change depending on the screen that we're on. Now, we can browse our dashboards. This home page is the default as of 6.3, but before 6.3, the default would have been the recommendations page, which is very similar to the old 5.x vROps. Now, we can navigate our dashboards from scroll buttons on the left and on the right, but we can also use our dashboard list, which is a much easier way to get the dashboard that you want, especially if you've got quite a lot of them. Now, I can select dashboards, and it will go straight to those dashboards. Now, if we want to set the recommended or the default dashboard that we want to see, we actually go up to our actions pane here. We can see set default, so I can set this as my default, meaning next time that I log in, that's the first page that I want to see. So generally you would make this something important, something that you would want to be seeing as soon as you're logged in, and that's what you make it. Now, as we can also see, is that we have the ability, and that's if you've got the permissions to, create and edit and delete dashboards from the home page as well. That will take you straight to those sections. You can also remove the dashboard from your menu. You might be given dashboards that you don't want to see, and you can remove them to make it less cluttered. Now, what we can also do is set up a rotation, an auto switch, so it can loop through dashboards. Here, I'm just going to loop through 3 of them. I'll select the vSAN troubleshooting, change it to 10 seconds. I might make it 5 actually. And we go to heat map. We go to the heat map one, we turn that on, make that 5 as well. Then we go to the vSAN entity usage, which is this next one.
We'll turn that on as well. Make that 5. And then we loop back to this troubleshooting. So that will make a loop. And it should cycle between these 3. We hit save. We have to refresh the browser for that to take effect. Now this dashboard here should switch to the troubleshooting one after 5 seconds. Now it should switch to the heat map one without me having to click on it or have the mouse on it, and this keeps your browser open. Now this is really good too for large monitoring screens in Knox or on an executive office, and it just allows it to loop through and stay on certain pages to show everyone what's happening related to what they need to see. Now on the home page too, is we can see these no matter which page we're in, but I'll cover them here anyway, is our collection notifications. So these has been in here since version 6.3, and that allows us to see that there's no issues with our data collections. We can also see our admin. Now we can log out here, or we can go to our user preferences. Now this shows us we can change our color scheme, and we can change our synchronized time, as well as the amount of metrics to show. I'll just leave this as default. And that's it for the home page. In this video we learnt about the home page, what we can do in it, what we can see in it, how we can arrange it. The next video is the alert page. In the previous video we looked at the home page, how to navigate around. Now we're moving on to the alert page. Within this page we're going to learn the ins and outs, how to navigate around, the types of alerts, how to filter alerts, how to own and cancel alerts, as well as opening an alert and taking a bit more of a deep dive into it. Okay, moving on from the home page is the alerts page. Now the alerts page is very simple. There's not much to it. As we can see, it's a place where we view all the alerts from the objects that we have got permission to see. So myself being an admin currently logged in, I can see every object within the system, meaning I can see all the alerts for every object. Now some people might only be able to see a handful of those, which means they'll only see those alerts to those particular objects they have permission to see. Now we see our alerts over here on the right hand pane, and on the navigation pane we've got our health, risk and efficiency. So this allows us to sort our alerts by those badges. So we can see efficiency, there probably won't be any, there really is. Risk and health. So risk is generally around capacity, and they're things that are going to probably cause you problems, so you should get on them as soon as you can. Health, on the other hand, are generally immediate issues that you should act upon right now. Now, as we can see here, we've got quite a number of alerts on the system here, and we can also see the status is active. We can filter up here, so I can cancel that, and now I can see inactive ones. What that means is that it was triggered, and it has since been resolved and been made inactive. I can reapply those filters, and as we see here we can put a lot of filters on here, so you can narrow down exactly what you want to look for. But I want status, and I'll choose my active, so I only see my active ones again. Now me being an admin and using this, I can go in and go, right, I want to work on this particular issue right here. I can then go, right, I want to take ownership. So we can see that's now been assigned, and it's not being open, and it's with me being admin here, but generally that would be your AD user once that's configured. Now once that's finished, I've fixed it, everything's good, I can then go in here and cancel that alert. And it's gone. If it isn't actually fixed, then it will reappear in next collection cycle. Now what we can also do is suspend alerts. So suspending alerts, as we can see here, allows us to, okay, there's an outage, we want the notifications to stop, and we need to work on it. So let's go 20 minutes to suspend that alert, so nothing more happens. And we can work on the problem and get to resolving it rather than being flooded by emails. Now we can open alerts in external applications. External applications are anything that this is integrated with. Now vCenter being the most prominent one, we can pick a virtual machine, say this one, and I'll be able to open that within the vSphere web client. It will take me straight to that machine, so I can administer it if I needed to. What we can also do is go into the alert. Now we can see it gives us a lot more details. We've still got our same options here to cancel, suspend, take owner, or release ownership if we don't want it anymore. And we can see the recommendation here. So some will have recommendations, some won't. This one's out of the box. And we can see a whole bunch of information about it. Now we can go back to the symptoms. The symptoms are what makes up an alert. And we can see the ones that have been triggered here. We can also go to the timeline to see when it was triggered. We can also have a look at the relationships to see, okay, what's the relationship of this machine? How's everything around it? Is it isolated to this machine? It gives us a nice breakdown of if there's any wider issues. Now we can also see metric charts, which is just the metrics of the machine, and notes if there has been left any, but there isn't here. Now we want to go back. We're happy we've fixed it. We can go back to the alert section. We can find that and we go, yep, it's fixed. And continue on resolving the rest of the problems, if there is any. And that's it for the alert section. In this video, we have looked at the alert section, how to navigate ourselves around, knowing the ins and outs, where to look, what to look for. The next video we'll be looking at is the environment page. In the previous video, we learnt how to navigate around the alert section, the ins and outs of it, and moving on, we're going to do the same with the environment page. Within this video, we're going to have a look at navigating through the inventory trees, where we can create groups and applications, and basically navigate all the objects that are being brought into vRealize Operations Manager. Okay, next up is the environment page. Now, we click on that. Funny enough, it's a picture of the Earth. And we first get prompted with our environment overview. So this is really just your groups, custom data centers, applications. So these are logical groupings of many different objects. They can be objects of the same type. They can be objects of different types. But it just allows us to group them. So we'll get more into what groups and applications are in later sections. But we can create and add groups and delete groups from this section. We can create and add and edit custom data centers, which are just logical groupings of different compute resources that we want to break out into different data centers. And applications, very similar to groups, just in a more tiered, 3-tiered, 4-tiered structure, and we can create and edit and delete them as well. Inventory also gives us just all the objects in our system that I currently have permission to see. Being an admin, I've got access to all objects currently in there, but a person logged in would only be able to see the ones they actually have permission to see. So down from the groups and applications here, again, we can go to them here. We can then go to our inventory trees. So this is where we can navigate to all our objects within the system. And it breaks them down to what type of object they are. So as the most used ones would be the vSphere hosts and clusters. Now if I was to select this, it'll actually go into a tree view, very similar to what you would find in the vSphere client. Going down, and I can break down to the hosts, and I can pick these hosts, I can pick virtual machines, I can pick data stores, and it will give me the information and breakdown of each one of those objects within the system. So you get your quick overview of a summary. You can then go into the alerts, if there is any. The analysis, see what capacity is remaining, time remaining. We'll get into all these in later sections and what they mean. We can go to troubleshooting. We can see the symptoms. We can go and have a look at all the metrics as well as the relationship of this data store to all the objects here in this particular scenario. Or we could go to this virtual machine and it will show the relationship to that from host to virtual machine to data store. We can go have a look at details, see some views if they've got any configured, and the environment, so a relationship mapping between the different components within vCenter. Now we can go back either we can select the different objects here, or we can go back to our environment page. Now here we can have a look at, say, networking next, and again, we'd get our tree structure just like we would see, but it would be only about our networking. Now if we go back, what I find most useful is the All Objects page. The All Objects page allows us to see all the objects in their tree structure, instead of having to go in and out of those different sections we're just having a look at. So I could go to vCenter, and it gives us all the different objects from vCenter. I can go to my host systems. I find it a lot more efficient way. I don't have to keep going back and forth between navigation panes, and I can get to those objects a lot quicker. But it also allows us to see anything we've put in through the API, which do not show up in this section, and we'll cover that in later sections within this course. That's it for the environment section. So the environment really is the way we navigate to all our objects, to dive into them to get a better look at their metrics, their health, their alerts, symptoms, relationships, etc. In this video, we have walked through the environment section of vRealize Operations Manager, learnt where everything is within that area. Next, we're going to move on to the content page. Hi, in the previous video, we had a look at the environment section and how to navigate our way through that and all the different areas within the environment section. This video is on the content page. Within this, we're going to have a look at all the different sections and areas of the content page to navigate through so we know where everything is, like group types, icons, and just all the other services like supermetrics, views, dashboards, actions will all be seen within this video. Next up is the content section, the little book icon. Now in this section is where we create dashboards, create views, reports, supermetrics, and is really where you'll spend most of your time within vRealize Operations Manager. And as we can see on the navigation pane on the left is all those different sections that we'll run through, and we can see the reading pane on the right. So by default, dashboards is selected first, and this is where we create, edit, delete, clone, and share dashboards. So we can see here, we can share them to different groups, we can import, we can export, we can save them as templates, we can add different tabs so we don't have pages on our home page worth of items. So most dashboards come out of the box, and with every management pack that we install, that adds more dashboards. And obviously we can create and clone our own. Views. So views can be used within dashboards, and this is where we do the exact same thing. We can export, we can import, we can clone, we can delete, we can edit, we can add new, and they also get added in with every management pack that we happen to install. Reports. Now reports are really a combination of views and dashboards. Now mainly they're made up of views, and we can put them together, or there's some pre-canned ones that come out of the box, and sometimes with management packs as well. Now here we're able to schedule reports to run at a specific time, to send an email out with the attachment. We can export, import, we can run, we can clone, create, edit, and make our reports here. We can also see the generated reports and delete any ones we don't want, download the ones we do. Alert definitions. So this is where we can create our alerts. So alerts are what affect our health or our risk, and we can see there some of the other box ones. We can export, import, again, clone, delete, edit, and add our new ones. Now generally these will come out of the box for the most part. Some will be added occasionally with management packs that you get, or you'll generally have to create your own. Symptom definitions. So symptom definitions are what go into an alert, and the subsections of an alert, essentially. And in here we can, again, export, import, add new, edit, delete, clone our existing ones, and we can see on the left-hand pane here that they're the different types of definitions that we can add, remove, edit, and actions. So actions is something we can't change. We can see what actions are available. Actions get added in with updates to vRealize Operations Manager, sometimes with management packs as well, and they use the vCenter Python Actions adapter that we can configure, and they're generally, I want to power off a VM, I want to power on a VM, I want to remove snapshots. They're very basic functions, but they give you the power to be able to trigger them from vRealize Operations Manager. Now, an action is added directly to a recommendation, which is next. So recommendations, they could be a page, they could be a one-liner, they can be a hyperlink to something else. Now, these are all out of the box. We're actually able to add new ones in, and what we can do is add a recommendation to a symptom, so that if you, the expert, is not around, that someone looking at an issue in vRealize Operations Manager can see that there's a recommendation to a particular symptom that might be just for your environment, but at least then someone can action that and know what to do. So I can have a whole KB article attached. It's really handy, and they're attached to your symptom definitions. Notifications. This is where we add our notifications. So notifications on particular alarms and triggers. This is where we can edit, delete, and add different notifications. Custom profiles. So custom profiles are an addition to your average large, small VM profiles. We can actually add different profiles in here of a particular VM size to meet your environment. And that's what can be done against capacity. This is where we create, edit, clone additional ones. And as you can see, there's none out of the box. You have to create everything yourself. Plugins. So we can't add any more plugins, but these are the plugins that we can see that they're online and they're available through vRealize Operations Manager. Supermetrics. So supermetrics, there's none out of the box. You have to create every single one of them, and this is where we create, import, export, delete, clone, add new. Group types. So groups have pre-canned types. These are all out of the box. We can actually add our own, so we don't have to be stuck with the existing ones. And this is how we can more granularly define the groups that we happen to create if we want to add them to something that doesn't happen to fit that's already here. Metric config. So when creating dashboards, this is where we create the XML file. The XML file allows the interactions between an object and, say, a scoreboard widget to relate to that object that we've picked. So it makes your dashboard interactive. We'll get into that when we're creating more advanced dashboards. As you can see here, this is where we can add and edit as well as delete XML files. Back in previous versions, you'd have to actually upload the XML file to your appliances to use. This is a nice handy way, easy to use within the UI. And icons. This is where we can change our icons of our different objects if we wish. And that's it for the content section. In this video, we navigated and walked through the content section of vRealize Operations Manager. The next video we're going to have a look at is the admin page, where we'll walk through that and learn all the different areas. Hi, in the previous video, the content page, or content section of vRealize Operations Manager, we navigated through that and now know the ins and outs and where things are located. Next up, we're going to look at the administration page. In this video, we're going to look at solutions, where they're located, policies, cluster management, and all the general services that are available under the administration pane. Next up is the admin page, the little people icon. Now this is where we do the administration tasks for vRealize Operations Manager. As we can see, on the left-hand navigation pane is all the different sections, and on the data pane we can see the relevant information for that section. So as we can see, solutions being the first one, this is where we add and configure additional management packs for vRealize Operations Manager. Some will be out of the box, like the vSphere one, but others are imported in by yourself and configured to connect to EMC or VRA, Hitachi, any endpoint management packs that are available. This is where they are installed and configured. Licensing is where we add, remove license keys or license groups. Credentials is where we manage our credentials from. Whenever you add an endpoint on a management pack, you've got to enter credentials. So you might have the same credential being used over multiple management packs, and instead of changing it on every single management pack, if you need to change the password, you can change it in a single location and it affects everything that uses that. This is where we can add, create or delete credentials. Policies are really the heart of vRealize Operations Manager. What makes it tick, what gives you the capacity management and the metric collections, and this is where we can see our active policies as well as create, add, edit, export, import additional policies within the system that can be used. We'll get more onto policies in the relevant section. Inventory Explorer. This is good. This allows us to see all the objects within vRealize Operations Manager. We can select an object and we're actually able to edit the objects, we're able to stop collecting on those objects, we're able to start collecting, we can add additional objects, we can completely delete an object. This is where we can manage objects if we need to, outside of the management packs. Object relationships. So generally relationships are handled by the management packs. They know which VM is on which cluster or which host or on which data store. But occasionally, where it's required, we need to add our own relationship in. So we can add a relationship between something that wouldn't have it normally, but we know there's a relationship there, so we want that reported on. We want to be able to see that relationship. So in here, we're able to create those relationships between objects. Maintenance schedules. So maintenance schedules are if you've got a patching night or something regular, you can set up a particular schedule so that alerts and outbound alerts aren't sent out because of it. So this way you can still collect the metrics, but you're not getting any alerts because of objects being down, because you know they probably should be down. This is where we can add, create and delete maintenance schedules if required. Access control is where we grant people access to different objects and different abilities like admin, or whether they want them to create a report or create views or read views or edit views. So it gives us that role-based access within the system. Here we can add local users as well as import from existing authentication sources, and we can create user groups, roles, and we can set a password policy if required. Authentication sources. So authentication sources are like our Active Directory. We can add our LDAP in here, we can add it, we can delete, we can refresh and recycle the authentication sources if required from this section. More on that under the security section of this course. Cluster management is where we can see the health of the cluster. We can see the cluster status, we can see the different nodes. There could be 1, there could be 10. We can stop nodes, we can refresh nodes, we can see how many objects they're collecting, the version, the adapter instances that happen to be working on those objects. Certificates. Every time we connect a management pack to an endpoint, say vSphere, vCenter, VRA, this is where it stores the certificate. We're able to delete, we can't add any certificates. When you add the endpoint to a management pack, it'll actually ask you to accept the certificate, and this is where it's stored. Outbound settings are where we set our outbound endpoints. Where do we want a notification to go? So it might be an email relay server, it might be an SMTP server, it might be a SNMP server. It could be a number of them. We can see here we've got the different options, which we'll go into in a later section, and this is where we can assign notifications to use the particular outbound settings, and this is where we create, edit and delete outbound settings. User audit. Security guys love this. So this is where we can see what all the users are doing. We can look at the user permissions, who has permissions to what. We can look at the system audit, how many objects I might be configured or collecting on, and also our system component audit. So we can see the different components and what's actually happening or available within those. Recent tasks, this is where we can see any recent tasks that might have happened. There hasn't been any on this system, obviously. Collector groups, so by default, all our nodes are in the single collector group. So a collector group can be made up of normal data nodes, it could be remote collectors, and it's what happens if one node was to fall over, that the other nodes within that group would take the management packs or the adapters, the endpoints that have been assigned to that particular collection group. So here we can edit, create, and delete collection groups. Global settings, as you can see, the global settings, so we can set our session timeouts, how long we want to keep our object history for, our capacity calculations, when do we want it to happen every day. We can edit all of these from within this section. We can't add any additional settings, we can only edit what's there. And support. Support is where we can see the logs for all the nodes. So only being one node here is I can see all the different logs that we might need within the system, as well as support bundles. So we're able to create support bundles and download them. For if you engage VMware support and they require you to configure a bundle or send them a bundle, a log bundle to see what's wrong, this is where you'd go to do it. The dynamic threshold, we can actually start and stop. So one day you might find the performance being degraded for whatever reason. And you come in here and you see your calculation is still under progress. So this could be because your nodes are too small and they're collecting too much information, but you're able to actually stop it and go, okay, we'll fix this later, or we can start one off if we happen to have missed it. So we can see my one only takes 13 minutes, but it gives you an idea of how long and what it's doing because it is very process intensive. Redescribe is generally after an adapter update, you'd want to redescribe your adapters. Generally you don't have to do this, but sometimes it's recommended to do after an update, or if the adapter is acting funny, but generally, if nothing's wrong, don't touch it. And that is it for the information section. In the administration page video, we have had a look through the admin section, can and can't be done, where things are located. This was the last video in the section. Throughout this section, we have walked through the home page, dived into the alerts, jumped through the environment section, crawled through the content, and sailed past the administration section. This will give you the knowledge of further videos on where things are located and how to quickly and easily navigate around vRealize Operations Manager. Next section we're going to learn about is security.
Welcome to the vRealize Operations Manager Guide by Scott Norris and Chris Slater, section Security. In this section, we're going to have a closer look at users, groups, roles, Active Directory and vCenter, and how they play a role in vRealize Operations Manager. Specifically, we're going to go through how do we create and modify these constructs to be able to give users and groups permissions to view certain dashboards and reports in vRealize Operations Manager. We'll be covering off certain use cases, such as how to create a user or group from scratch, and how to give them just the information they need to do their role within a certain organization. In this video, we're going to take a specific look at how users play a role in vRealize Operations Manager. We'll cover off how do we create local vRealize Operations Manager users for use cases where an external directory may not be present, how do we import Active Directory users or users from an external directory source, and how do we assign roles and permissions to users, covering off use cases such as a security user or an administrator, executive who may only want to see access to a certain part of the UI, certain dashboards for certain use cases. In the next video, we'll cover off groups, how to create groups, assign groups to roles, and assign groups to certain use cases that we'll work through as well. Right, now let's get started. Now the first thing we need to do is to log into the vRealize Operations Manager UI. Now right now we're going to be logging in as a local user, as a default admin user account. But by the end of this video series, we'll be able to log in as a specific user based on specific use cases. So now that we've logged in, we've gone through the UI in the previous section. Let's go to the administrator view where we can actually go and administer user accounts. So under the administration view, we see on the navigation bar on the left we have access control and authentication sources. Access control is where we're going to go through and create our various user accounts or import our user accounts from a directory source, create and apply our groups, our roles, and our password policies that we'll go through later on in this section. Under the authentication sources section, this is where we can add external directories that we can import users from for external sources. So the first thing we're going to do is we're going to go and create a local user account. This is done by selecting the Add User or Add button at the top left of the screen. So here we can fill in the basic information about the user, such as the username, password, the first name, last name, email address, description, and we can fill in there's also some checkboxes around, do we want to disable the user, or do we also require that they change their password on first login? Now, the next option we have is, do we want to assign the user on its own as part of this creation process to any existing groups or directly to any objects, right? So in this case, what we're going to do is we're going to say, yes, he's a member of the IT security group. And now we can look at assigning objects to the user. In the case of the group that we've just assigned, that group doesn't yet have any objects assigned to it or any other permissions. So therefore, this user still won't be able to use anything inside vRealize Operations Manager. Therefore, we can go directly to the objects and apply objects directly to this user account. We'll be covering off how to add roles to users and groups in a later section. So I'm going to choose my pre-existing role within the system for the read-only role. Once I've selected the role, I have to check the box to say, assign this role to this user. And then I can choose the hierarchies that I want to apply it to. Now, by default, the adapter instance is selected. We have a couple of different options here. The first is we can allow access to all objects within the system, essentially giving the user anything, any object or any that is inside vRealize Operations Manager, any context, this user will be able to see it. But in our case, we're going to do some more fine-grained role-based access control. So if we unselect that, the first thing we're able to choose from is possibly the adapter instance. So in this case, maybe, well, this user's from security, we'd only wanting to give them access to a specific adapter instance. This is quite a macro level of permissions that can be quite useful. For example, if we have a team who specifically looks after Amazon Web Services machines, maybe we want to give them access to anything that comes from the management pack for AWS. At the same time, we can say, well, look, maybe we want to give them access to anything that comes from vSphere, for example. Now, in our use case as well, we can even go further with the hierarchy and choose, well, maybe the security team is only interested in looking at a specific object or hierarchy within the system. So we can select maybe vSphere hosts and clusters. Under the vSphere adapter, we see our data center and we see our cluster. Underneath, we could select possibly even individual resource pools, individual hosts. We also have the option to propagate permissions. When we choose propagation, the user will get access to that object as well as all its child objects. So in this case, we have virtual machines. Now in our situation, security are going to need to have access to look at the entire system. Any object, any view, but we don't want them to be able to change systems, which is why I've given them the read-only role. So what I'll do is I'll unselect the choice we've made here, and I'll say they'll have access to all objects in the system from a read-only view. Once that's been done, I can select Finish and finish the Add User creation wizard. So now that we have created a local user and assigned it to a role, it's time to do the final task now of importing a user from a directory source, such as Active Directory. So similar to when we create a local user, instead of clicking the Add button at the top, we have the Import Users button to the right. Now, for this process to be successful, we have to have already added in the external directory, Active Directory source. We'll be covering the process of how to do that in a later video. So once we've added the external directory, the next thing we do is to select the Import Users button. So we select Import Users. Now, by default, our directory will already be selected. If we have multiple directories, we can choose from a drop-down list. We can also add a directory in here as well if one doesn't exist. So the next thing we do is a search string. So when we look about adding a user, we are adding an individual user. We can use Advanced to search specific trees of Active Directory, ROUs, but in terms of search string, we'll simply say type the username, for example. So if I take Jason, who's my user, do a search, Jason, that's him. Now that we've selected Jason, We are presented with a similar group membership screen to when we're creating a local user, so we'll add into the same group, IT security, and we have the same ability to apply roles and to various objects throughout vRealize operations. So in a similar way, what we did with Max, we'll select the role. So the role might be the same role, read only in this case. We'll say yes, we want to assign the role to this user, and then once we've selected that we will assign the role, what objects will we assign that role to? In this case, we'll do the same process, which is say we'll allow all objects, access to all objects in the system with the read-only role. Then finally, we click Finish. Now, once that's done, we see what we've done is we've added JSON and we've added Max into vRealize operations under the user. We can see with the User Groups and Permissions tab that they're a member of the IT Security group. So they're a member of the Everyone group. That's always added by default. And finally, we can see in the Permissions tab, they have a read-only permission, and that's on all objects. And that's the process of adding in users. That's now complete. So in this short video, we've covered off the process of creating a local user and assigning that user to a role, the read-only role, as well as all objects in the inventory. And we've also covered off the process of importing a user from Active Directory and going through a similar process. Now in the next video, we're going to do a similar type of activity, but for groups. And that's how most enterprises will entitle users to use vROps to see objects and dashboards and reports throughout the system. Welcome to the next video in the vRealize Operations Manager security section. In this video, we'll be covering groups. So in this video, we'll be covering how we create local vRealize Operations Manager groups, how we import existing Active Directory groups, and then how we can assign roles to these groups inside vRealize Operations Manager. Now in the previous video we showed you how to create users and assign roles and permissions. This time we're going to go through groups. Groups are a far more common way of applying roles and permissions inside vRealize Operations Manager, as you can easily apply a role and permissions to multiple people at the same time, and if people come in or out of groups within the organization, their permissions are automatically updated. So we start off with the same way that we started when creating users. So under the administration menu, we have access control. So the first thing we're going to do is create a local group. Now, just like users, we can create local groups with the plus button, or we can import groups from a directory source like Active Directory with the import group button. Let's go ahead and create a local group first. So my group name. Now, in this case, my group is going to be my network and security. I'll just add that it's my local network security users. Now, what I'll do first is, in a similar way when we added local users, when we create a local group, we can actually choose what members we'd like to put in the group from the start. Now, we can always add members at any other time. And when we add users, they can be local users or they can be directory users, such as Active Directory users. So we've got a mixture here. So what I want to do, in this case, I'm going to add a local user. That'll be my local user here, James Bond. Now, in the same manner when we create a user, when we create a group, we can apply that group to objects straight away. Now in this case, what I'm actually going to do is say that this user is a networking security administrator, and they're going to have administrative access over all parts of vRealize operations that are to do with NSX for network and security. So I'm going to assign them the role administrator, assign this role to the user, or in this case the group, but I won't be allowing all access to the system. In case, what I'll be doing instead is I'll be selecting the NSX adapter, so I'll say that they have access to the NSX adapter, and I'll also be saying that they'll have access to any of the NSX hierarchies in the system. Right, now once that's been done, we'll see in the User Groups tab that our user group shows up. In this case, it's our local group. If we have a look in the User Accounts tab, we can see any users that are there. We can see we have our local user, James Bond. In this same screen, if we want, we can go and add any additional users. So if I like, if I change my mind afterwards, I can say, well, yes, I want James Bond. But at the same time, I'd like my Active Directory user, Jason Bourne, to also be in the same group. And as another day 2 action, we can also go into the Permissions tab and have a view about what permissions have been applied based on when we create the group. So we can see here that it's got the administrator role and it's applying to certain object hierarchy and the number of objects that's been applied to. Now that that's done, let's repeat the same process but showing how we can do an Active Directory group. To import an AD group, it's very similar to the process of importing an Active Directory user. So under the User Group tab, we select the Import Group button, and we do a basic search for the group we're trying to find. Now in this case, my group is called vSphere Global Security Admins. So I do a search for vSphere, and there it is, vSphere Global Security Admins. I'll check the box. Now in the same process to when we're importing a user, we can then decide, well, once we've selected what group we wish to import, the specific roles or permissions that we'd like to apply to that group. So in this case, I'm going to apply the read-only role. I'm going to assign the role to the group. And in this, in this case, I'll allow the users in this group to see all objects in the system. And then we go finish. Now that our group's been imported, we can see that it shows up under the user group list, vSphere Global Security Admins, part of Active Directory. We can see down in the permissions view that it has the read-only role applied, and it's been applied to all objects. Now one thing that's a little bit different with Active Directory groups versus local groups, if you go to the user tabs, you'll see we've already got a user account that's been added in, Jason at the Active Directory domain. Now this came because Jason Bourne is a member of the Active Directory group, and that was automatically imported. Now one difference between local groups and AD groups is that we can't manually add and remove users from the groups. This is obviously done with inside Active Directory, so there's no need to do it inside vRealize Operations Manager. That now concludes this video where we covered how to create local vRealize Operations Manager groups, how to import Active Directory groups, and then how to assign either local or Active Directory groups to roles and permissions and hierarchy within inside vRealize Operations Manager. Now in the next video, we're going to cover off roles. We've already been using roles quite extensively, such as the read-only role and the administrator role. Now we're going to show you the process of how to create these roles and how you can apply different permissions to different roles. Welcome to the next video in the vRealize Operations Manager guide. In this video under Security, we're going to be covering off roles in vRealize Operations Manager. In detail, we'll be going through how to create roles in vRealize Operations Manager and assign those permissions. And then once those roles are created, how can we assign them to different users and groups? We're also going to go through some of the out-of-the-box roles and some of the common configurations or roles that are commonly created in different use cases. And to start with roles, it's in the same section where we do users and groups. So we head to Administration, then we have the Access Control section. Now on the third tab, we have roles. Now we've been applying roles already to certain use cases, which is when we apply a certain role to a user or group and we apply it to the hierarchy like we've been doing in our earlier videos. Now we'll go through the process of creating a role and what does a role actually mean. So a role is the actual permissions that you're applying to the user group in the context of the hierarchy. So if you have a look at a default role, such as Administrator, you can see the permissions on the bottom right hand side. Now in the Roles tab, the only thing you can really do is create and edit roles, and the editing of roles is really just changing the permissions that can apply. So for example, if you have a look at Administrator, you'll see that pretty much all the permissions are applied out of the box, and there's quite a lot to go through. If you have a look at some other out-of-the-box roles, such as Power User, you'll see there's a role description. So all the privileges except those related to user management, cluster management. So obviously the idea here is that this is a role where users have got permissions to configure almost anything they like with inside vRealize Operations Manager, but they don't have permissions to do actions or things that could actually make a change inside vCenter, for example. Now we can see this because at the bottom right, we can see the content is fully selected, which means this permission has full permissions to create alerts, delete alerts, dashboards, groups, metrics, notifications. All sort of permissions related to content this permission has effect on. Now if we go down and have a look at environment, for example, we can see that some of the boxes aren't fully selected, some of them are grayed out, some of them might be deselected. So for example, if we look at administration, we can see that a power user doesn't have the ability to create or edit roles, which is what we're doing right now, and update password policy, etc. This is something that typically wouldn't be needed for this sort of role. Now when we create a role, there's two types of ways we can start. We can create a brand new role from scratch by selecting the Add button, and this could be content creator, for example. Now when we create a new role, by default, the role won't have any permissions applied to it, so you're sort of starting from a blank slate. That's one way of starting, and in this case we could say, well, this role has full permissions over the content. That's done by selecting the Edit button and saying Content. Another way of doing it is to clone an existing role. So if we find a role that is pretty much what we need out of the box, but with only minor modifications, we can select a role, such as Read Only, and then we can select the Clone button. So in this case, we'll clone the Read Only role. And the use case we're going to do here is the Project Manager. So what we're going to say is that a project manager is able to log into vRealize Operations Manager. They're able to view everything in inventory, but they're not really able to make changes to anything. The exception will be the Projects tab under Capacity Management, so they can create and model projects based on their incoming needs. So we'll say Read Only role. Once we've cloned the role, the next thing we need to do is modify the permissions. So we'll edit the permissions. We'll by default already have the read-only role permissions applied. We can see there, for example, alerts, dashboards, and if we look at alerts, for example, we can see they can read, but not create, not edit, etc. If we look at the environment, similar sort of views. Now, if we look under project management, we can see that they can view projects, but they can't edit, delete, create, etc. So what we'll be changing in this role is we'll say that this role has got full permissions over project management. We'll then update the role. With the role now created, we now have just the final task of applying the role to a user or group, and therefore the permissions will become active. So we have our role, Project Manager, which is our copy of Read Only with the project access. If we go to our User Accounts tab, we might apply this directly to a user. So we have our user, Ben the project man. He doesn't currently have any membership apart or permissions apart which are blank. His user group is simply just the Everyone group. So what we'll do with Ben is we'll edit his user account, and then we can assign groups and permissions. So we'll go to the Assign Groups and Permissions. We won't assign him any groups for now, but we can go to the Objects tab. Now in this case, what we can do is first we can select our role that we just created. So in our role list, we'll have our new Project Manager role. Once our role's been selected, we'll say we want to assign this role to this user. And in this case, we'll allow project management and the read-only role to be applied across all objects in the system. Now in the next video, we'll actually show you the process of how you create an Active Directory instance inside vRealize Operations Manager, so you can import users and groups from Active Directory, just like we've been showing you in this section.
Welcome to the next video under Security for vRealize Operations Manager. In this video, we'll be covering off Active Directory. In this video, we'll be going through how to create an Active Directory authentication source, and then how to import users and groups from Active Directory into vRealize Operations Manager. Now, during the previous videos in security, we were importing users and groups from Active Directory. In order to do this, you have to first set up an Active Directory authentication source. In this video, we'll take you through that process. So the first thing we need to do in the same section, under Administration, we've got Access Control, which is where we have been creating and importing users and groups from Active Directory, but right underneath we have Authentication Sources. In Authentication Sources, I already have one Active Directory added, the one I've been using for the demo so far. In this video, we'll add a second Active Directory source. Now, the real-world use cases around this might be that you've got other users from other parts of the organization, they're in separate AD, and they might need to be imported into the system for access to certain dashboards or roles within vRealize Operations Manager. So to start this off, we click the plus button to do the add of an authentication source. The first thing we need to do is select the source type. We'll discuss this as a SAML type in a later video. So for the source type, we select Active Directory. We need to give it a display name. This is simply a display name so we can identify what directory it's coming from. So I'll add the name of my Active Directory. And then we can choose Basic or Advanced Integration. If we have a look at Advanced, we can see we have to manually enter base DN details, etc. This may be useful if we want to limit the scope of what users and groups are being pulled into the vRealize Operations Manager for a particularly large Active Directory. If we select the basic option for integration, first of all we need to pick the domain or subdomain. I'll enter that here. We have an option whether we want to use SSL or TLS. And then next we add the username. Now, the username only needs read permissions in Active Directory to be able to read the users and groups that we're going to be importing. So in my case, I'll be using a service account. Finally, we put the password in for the service account. And before we click OK, a wise thing to do is do a quick test to see if we can authenticate successfully against that environment. So we'll run test. The test connection was successful. Once that's done, we can click OK. And the directory's been added in. It'll have an auto synchronization status, but if we want to be able to start in users and groups from it straight away, we can select the Active Directory and then select the Synchronize User Groups button. We get prompted, yes. Once that's done, we can see it was last synchronized very recently. We're now able to start in users and groups from that directory source. So, to prove this point, if we go into Access Control, just like we've done in the past, we're able to import user groups and users. Let's try importing a user from that domain. Import user. Now in this case, we need to change the directory it's coming from, because it's now coming from my second Active Directory source. We can also add directory sources directly here as well if we wish. So we added Jason in the past. Let's try Jason's dev account. Do a search. There it is coming from that Active Directory source. We can see here. So I'll select his account. And just like we've done in the earlier videos, we can add into any local security groups if that's required, or we can directly apply his permissions to the hierarchy straight away. So we can give him the read-only role, and in this case, we'll give him the read-only role to all objects within the organization. Now that we've added Jason's account from that directory, one thing that might be worth showing is how we can actually now log in with these users from other directory sources. Up until now, we've been doing all this work as the local vROps admin user. So to do this, we'll log out of the vROps. And now that we have AD integration enabled, we can actually choose the Active Directory that we'd like to log in with. So in this case, we just added Jason's account from the dev domain. So we'll select the dev domain as the authentication source, enter his user account, and the associated password with an Active Directory. We've now logged in as Jason's account, and this means that any dashboards that he created, any views, etc., will have his name on it as the creator and the author, and eliminates the need for having people having to share dashboards. So you can now, each individual user can create their own dashboards for their own use cases without overriding each other. With AD integration now complete, in the next and final video of the security series, we'll show you how vCenter users and groups are treated within vRealize Operations Manager, and how to enable the SSO SAML authentication. Welcome to the final video in the security section of the vRealize Operations Manager guide. In this video, we'll be going through how vCenter users and groups differ from local and Active Directory users, local and groups. So in detail, we'll be going through how vCenter users are given permission to vRealize Operations Manager by default, and how vCenter users and groups differ from local vRealize Operations Manager users and groups. Now in this final video, we'll be covering off how we import or how we use vCenter users and groups as opposed to local or AD users and groups. In the videos so far, we've been dealing with local users, such as, for example, James Bond, and we've also been importing Active Directory users, such as Jason Bourne's dev account. Now we're going to show you how vCenter users are treated. Now, with vCenter users and groups, vCenter must already be added as an endpoint under the vCenter solution. Once that's done, users are automatically given access to vCenter objects or vSphere objects that they have permission to already inside vCenter itself directly. Now to see this, if we have a look, we can see we've got our local accounts, our AD accounts, and we have a few vCenter accounts already in the system. But what about a new user who's come on board? How are they treated? So for example, if we quickly swap across to the vSphere web client, we can see here my users who have got permission directly inside vCenter itself. Now the user I'm interested here in is the first one, D King. He's an administrator inside vCenter, so what access or how will he be treated inside vRealize Operations Manager? Now he's automatically given access to vRealize Operations Manager because he's an administrator or he has any privileges inside vCenter itself, but you don't see that until the first login. So for example, if I log out, we then choose the authentication source as the vCenter server. So we choose all vCenter servers. enter the username, and log in. And as you can see, what was interesting is we didn't see Daniel's name in the list of users, but we've still been able to log into vRealize Operations Manager. Another few interesting notes is if we have a look at a few various options within vRealize Operations Manager, we'll see that he only has access to certain systems. So for example, if we go to the administration view, we can see the access control, but he wouldn't have permission to add or remove user accounts. Also, one thing to take a note of inside access control is now that we've logged in successfully, we'll see Daniel's account has been automatically added in to vRealize Operations Manager, with the source type being a vCenter server group. Now, we can't edit Daniel's permissions inside vRealize Operations Manager. He's only got access to vSphere construct. So for example, if we go home, we might want to look at certain aspects of the environment under this user's account. So if we go to the environment view, we can see there's various inventory trees. And if we go, well, I'm interested in the vSphere world, I'll still be able to see all my resource pools, clusters, virtual machines, all those various aspects that involve vCenter. If I go back a level, what if I'm interested in something else? What if I'm interested in my Amazon regions, for example? So if I select my Amazon resources by region, you'll notice that there's nothing there. It's blank. It's not that there aren't any resources inside vRealize Operations Manager, but this user doesn't have access to see them. This is a very important aspect to keep in mind, that users who've got permission through vCenter will only be able to see and interact with vSphere objects. So if we have a look at the solutions view, for example, which is being covered off in the solutions section, we can see there are solutions and management packs for lots of different use cases, such as Tomcat, Postgres, Microsoft SQL Server, NSX, Amazon, Active Directory, EMC Storage, UCS Compute, the list goes on and on. So it's important to keep in mind that if you want to give your users access to a whole range of solutions and management packs, and have that single pane of glass from end to end, it's important that they're added in as either Active Directory users and groups or local users and groups. That now brings the security section to a conclusion. In this section, we have discovered how to create vRealize Operations Manager local users and groups, learned the preferred method of importing and using Active Directory users and groups, sped through how we can add an Active Directory as an authentication source, created roles with specific permissions based on use cases, applied roles to inventory objects with users and groups, and finally learned the difference between vRealize Operations Manager users and groups and vCenter users and groups. In the next section, we're going to be going through the exciting world of solutions, where we install solutions and management packs for infrastructure level elements such as storage arrays and blade chassis, all the way through to the virtual infrastructure layer, and finally all the way through the application layer covering databases and other web-based applications.
Hi, and welcome to section Solutions. In this section, we're going to take a look at what are solutions, how do we install solutions, and then once they're installed, how do we then configure the solutions that we want. The first video is what are solutions. In this video, we're going to take a run through exactly what solutions are, the types of solutions that are available, and the levels of integration that each solution provides. So, what are solutions with vRealize Operations Manager? Well, at the end of the day, solutions are just plugins, or sometimes referred to as management packs. They are what allow vRealize Operations Manager to reach out and grab data from different endpoints. Now, these solutions come in a lot of different shapes and sizes. Some have more integration than others. For example, some are just plain endpoints. They'll collect the data, and we have to manipulate that data how we want to. Others have a bit more frills to it, meaning that they will come with dashboards that we can use out of the box. They will come with views and reports that we can use out of the box or use as guides. And then finally, the most integration is actually plugging into the analytics engine of vRealize Operations Manager and doing capacity planning and reporting, etc. Now, these solutions come from various different parties. VMware supplies solutions for VMware products and some other external products. Blue Medora, for example, is a third party that supplies a lot of different solutions for F5, for example, and HP and Dell and Cisco all provide solutions for their technologies, like UCS blades, etc. Now, solutions are located within the admin tab, and it will be the first one that's selected on the navigation pane on the left hand side. Now, if you've got a fresh install, you'll be able to see the out of the box ones, which is vSphere, and that will allow you to connect up all your vCenters. You'll also see Operation Systems, Remote Services, the vRealize Operations Management, as well as the Login Site Adapter. Now, solutions can be downloaded from the Solutions Exchange, which is shown up on the screen at the moment, under the VMware Cloud Management Marketplace. Now, as we can see, there's vRealize Operations Management Pack, there's 130 there. We'd actually go into that because not all of them solutions or management packs. Once we're in this, it's broken down into different tools. So what we're really looking for is these advanced management packs. Now, the rest of them can install and work and add different functionality, but these are the ones that supply those solutions with really good integration. Now, as we can see, there's many different types. There's a lot from VMware. There's also a lot from Blue Medora and AWS, etc. Now, it's good to note that not all solutions are the same. So most of the VMware ones will be kept up to date as new releases come out. Other ones that are from third parties may not always be up to date, so it's always good to be sure. Through the Solutions Exchange, you can click on the one that you want. You can have a look at the overview, make sure it does what you want, and under Tech Specs, they should mention which version of vRealize Operations Manager the plugin supports, and which version of the endpoints it also supports. Now, some plugins or solutions are paid, meaning that you have to pay a licensing cost. Now, majority of the VMware ones are free. The only one that has a license cost associated with it is the V4H, which is the Horizon View plugin for vRealize Operations Manager. And ones from Blue Medora are generally premium and they have a cost associated with them, while others are just free and come as part of your purchase of the particular technologies. It could be Brocade or EMC, etc. So once you download it, you download these as a .pack file, and that's when we get into installing it within vRealize Operations Manager. Now, the ones that you do have installed here, it's good to note that you've got your versions, the ones you downloaded. You have a description of what it is. You have who it's provided by. So you can see all the ones here are provided by VMware, even the AWS one. And we can also see the licensing. So all these ones here are free. They have no licensing support. And obviously the adapter status. So we can see what's configured and what isn't. Within the solutions page, we can also actually list by configured or not configured. So I've only got 3 configured here at the moment, and by clicking on them, we can see the endpoint where I've only got 1 vCenter. If I had 4 vCenters attached, they'll all be sitting under here, and we can see the status of them. In this video, we've talked about what solutions are. We've had a good overview of where to find solutions, what they connect to, and how they just generally work. Next video, we take the next step and install solutions. The previous video gave us an overview of what solutions are. In this video, we're going to have a look at installing a solution, how to add a solution, how to upgrade a solution, and how to view the dashboards that a particular solution supplies. Installing the solutions is quite easy. First, we need to make our way to the administration section, and solutions is highlighted on the left in the navigation pane. Then we see all our solutions here. We want to add another one. We hit the add button. Now we've got to select a solution. So we select the one that we've downloaded from the Solutions Exchange or from another third party or a vendor. We look for them. Here are some. In this case, we'll do the NSX one. Now you'll notice there's an install pack even if it's already installed. This is how we'll force install a package if there's something broken or we just need it installed again. and then there's the reset content. So when upgrading a solution, you can say, I want to reset all the default content that that solution provides, meaning the dashboards and reports. But if you've modified these, you can not select that, that's fine. But it's good to always take a copy of the ones they supply and then you modify them and leaving the default ones alone. So once we have our pack file selected, we hit the upload. So this upload is going to do a couple things. It will stage this file to every node that you have in your vROps cluster, and then it will install it on every node that you have in your vROps cluster. Now that it has been staged to all the nodes in the cluster, this one there's only one node, it'll say that the pack is valid and it's right to move on to the next. So we hit next, we accept the terms and agreements, and then as soon as you hit next, you'll see that it just goes into install. So you don't actually go to the install page to click install, it'll start straight away. So we've got to wait till this installs on every one of the nodes within the cluster. Okay, now that it's finished, we can see all the steps that it's taken. We hit the finish button. So now we look at the solution we just installed, which is the management pack for NSX vSphere. We can see that none of the adapter types are configured, and this one actually comes with two different ones. So here we want the vSphere adapter. We select configure up there with the cogs, and now we give it a name. We'll go 01 because you can have more than one. We'll go the host, the virtual center host in this instance. If you want to enable login site configuration, we'll leave as false. Now credentials can only be used per adapter type, meaning that I haven't installed this solution before, so I won't have any credentials. But if I have, even if they're the same credentials for vSphere or another solution, you can't actually pick them because it's a one-to-one relationship between the credential and the solution type. So we want to add a new one here. We'll just call this NSX credential, NSX username, admin, password, vCenter username, and password. Hit OK. Now we should be able to test this connection. We should get the certificates. OK. Test was successful. That's great. Now there's always usually an advanced settings section of a solution, meaning that this will differ depending on the solution type, just like everything we've just done. Most things will have username and password, but general different settings. In here, the only advanced settings is the collectors group. So this is actually a vRealize Operations Manager setting, meaning that we can set the collection group that's going to do the collection of the data from this solution. Now, by default, there's the default collectors group, and it'll have all your nodes in here. All my nodes will be listed down here. So this allows, if I had 3 nodes, for example, and I select the default collector group, meaning that if one node was down or it failed, my collection would fail over to another node within that group. If I just select one, meaning that if that goes down, then my data's not going to be collected. So for now, I'll just leave it as the default collection and hit save. It's been successfully saved. We can go back here and we'll see that it's starting up. And then in a little bit, it should say that the collection state is running and data is being received. And we can see that the data is in collecting state and data is now being received. Now we want to go and see that data. We can look in our environment overview and we'll be able to see that we've got all these new objects that we can go in and dig around. That's my NSX name. Now there won't be any data immediately. It will all be these nice grey question marks. But as it goes through its collection cycles, that data should start appearing, and the analytics, so your health and risk and everything, will start being green or red or whatever it determines it should be. Now, if we want to have a look at the objects, we should be able to see our NSX vSphere adapter there, and that's got all the objects that it's now looking at. Now, if we go back to our home page and we want to have a look at the dashboards that this solution has supplied. And look in here, and there's our NSX vSphere, and these are the dashboards that it's given us. So we can have a look at the main. Now it's already starting to get some data back, and the vSphere topology. So these all, we can use these, or we can take a copy of these and make our own changes. But what it does is it just gives you something to use straight out of the gate, and then you can modify and change later. Now, we'll go on to updating a solution. We want to select a solution here, so for example, I'll use the vRealize automation. We've got version 2.0.3, and we want to upgrade that. So what we'd do is we'd go to add new, just like we would if we were installing a new one. We'd browse to the one that we've downloaded. There it is, 2.1. Open. And we do the same thing. We'll upload. That'll do a stage. Now we can see it's been uploaded, and the pack signature is valid. We've got a new version, and it's allowing us to proceed. We go next, accept the terms and agreement. Now remember, if we hit next, it goes immediately into install. That's finished, so we hit finish. Now we should see new management pack as the new version. In this video, we had a look at how to install and upgrade a solution, and we also had a quick dive in and configured a solution to show us data within the dashboards that were supplied. In the next video, we take a deeper dive into configuring solutions, where we'll configure multiple solutions and show the differences that there are between. In the previous video, we checked out how to install solutions and had a quick glimpse at how to configure one to get data coming in to use the dashboards that they supplied. In this video, we'll be looking at configuring solutions, the different configurations, the general configuration settings that are the same across all solutions, as well as editing the different configurations. Okay, configuring solutions. Configuring solutions is a fairly easy process, as long as you've got the details, login details for the endpoint that you're trying to connect to. Now, one thing to remember is that solutions come in different shapes and sizes, which means they've got different configuration items and different settings that are required. This makes sense when you've got an EMC analytics solution connecting to arrays, or you've got the vRealize automation solution connecting to vRealize automation. They've all got different configurations. Now, one thing that's common across all is generally username and password, as well as a collector group amongst a couple other settings, but we'll look at doing that now. Now, to get to configuring our solutions, we want to first log into vRealize Operations Manager and select the administration section. Now, if solutions isn't selected by default, which it should, select that, and then we've got all our solutions here on the right hand pane. If there isn't one here, install it first, which was the previous section. And we select the one we want to configure. So here I'll select vRealize Automation Management Pack. There's nothing configured here yet. Hit the little cog icon. And first we need to give it a name. This is just for the instance, so we can have many instances of this. So I could connect this to 5 vRealize Automation installs, but we only need one. So let's just give it a name, VRA, give it a description, give it the address that we want to connect to. So we go here, which is all the tenants and credentials. So I want to give a new one. Actually, let's edit the old one. So we can see that this has multiple credentials. This is because this is what this particular solution requires. It requires a sysadmin and a super user password to get different elements. So here we can see I've got my sysadmin, my super user password inputted there. I'll use that. We'll test the connection. Gives me a certificate. Another certificate. And if all goes well, test successful. Awesome. So now we know that connects properly. And advanced settings. So in here we've got two different, so you nearly always see collectors and groups. Now, as we've gone through this previously, is that we could select that or any other node, and it means that only that node will collect the resources. But we don't want that in case that node fails or gets removed. So it's generally better to select a group. Now the default collector group is all the nodes, generally, unless you go in and edit it. And auto discovery, we want it to auto discover everything. So go Chrome, we'll save those settings. And it should save. Yep. Done. Now you see our VRA instance over there. Close that off. And we can see that it's starting to collect, and soon that should be okay. Let's have a look at another one. Let's have a look at the management pack for AWS. So we'll give this a name. We don't have any credentials available, so add a credential, and we can see we've got proxies and usernames and proxy domains, and it's very different compared to the credentials that we required for vRealize automation. And the same will be for multiple other ones, they'll all be different. So here we need the credential name, so we'll just give it a name. Then we need the access key. Then we need the secret key. I'm not using a proxy, so I'll leave it at that. We test the connection, and again, hopefully, we will be able to connect. Connection successful. Excellent. Advanced settings, take a look at that, and we can see this one's got a lot more advanced settings. So we've got again our collectors group, and we've got our services. So what services we want to bring back. So these are EC2, S3, etc. from AWS. What regions we want to collect from. So if we want to collect from a couple of regions, auto discovery, and then we can whitelist and blacklist using a regex. But in this case, I'm not going to do any of those. I just want to save it. Saved. Okay. And we'll say that will start collecting, and that should go back to collection status. Let's have a look at our automation and see we've now got data receiving. And that's it for configuring solutions. In this video, we have looked at how to configure two different solutions or management packs and seen how they're very different, and each one that you do add will be different slightly in its own way. This is the last video of this section. In this section, we have learned what solutions are, how to install them, how to update them, as well as how to configure them and start bringing the data in so that we can now start to use them and create dashboards. The next section is on badges, which uses the data that these solutions are now brought in.
Welcome to this section. We're going to be covering off badges inside vRealize Operations Manager. In this section, we'll take a closer look at what are the badges, including the major and minor badges, and how they assist administrators with troubleshooting issues. Understanding the health badge, including the workloads badge, anomalies badge, and faults badge. Understanding the risk badge, including the time remaining, capacity remaining, and stress badges. And finally, understanding the efficiency badge, including the reclaimable capacity badge and the density badge. In this video, we're going to go through an overview of the badges and how they assist administrators in identifying and troubleshooting issues, go through the major badges and their relationship to the minor badges, and finally, go through the changes between vRealize Operations Manager 5.x and vRealize Operations Manager 6.x. A vRealize Operations Manager badge is a graphical representation of the state of the current environment or objects. A badge can range from a few metrics to millions of metrics. It provides a summarized piece of useful information that will sometimes take an administrator hours or even days to collate manually. Now, if we have a look inside vRealize Operations Manager, one of the main tabs is the Recommendations tab. This is found in the dashboard lists under Recommendations. The Recommendations tab actually highlights some of the major badges and some of their associated alerts towards those major badges, which we'll go into a little bit later on. From a high level, we can see the major badges: health, risk, and efficiency. One of the most powerful and unique aspects of badges is that they allow administrators to view the same important information all the way from the VM or data store level all the way up to the vCenter level. This is because all objects can have the same set of badges applied to them. They may just slightly differ in the way that those scores and the badges are calculated. By enabling all objects to have the same set of badges, it means we can leverage the parent-child relationships inside vRealize Operations Manager to roll badges up to high-level scores. For example, if we have a series of virtual machines that have got unhealthy health aspects to them, we can then roll that health aspect up into the host aspect or the data center aspect, depending on how important that machine is in the environment. The badges in vRealize Operations Manager can be split into two distinct categories: major and minor badges. The major badges are health, risk, and efficiency. These badges are represented by the color, red, amber to yellow, and finally green, red indicating there is an issue or an alert with the environment. Unlike the minor badges, the major badges don't have a score on them. We'll touch on this in just a moment. What we might do now is quickly have a look at how the major and minor badges used to look in the previous version of vRealize Operations Manager, when they could all be seen on one dashboard together. This can be seen in the classic dashboard, which is available in vRealize Operations Manager as a disabled dashboard. You can simply then enable the dashboard to get the classic dashboard to show up. If we have a look at the classic dashboard, we can see some of the relationships between the major and the minor badges. Let's start with the health badge. As the definition says underneath, health is based on the alert definitions you configure to impact the health score. We'll touch on alerts in the later section. But underneath the health badge, we can see the workload badge, the anomalies badge, and finally the faults badge. If we have a quick look at the workload badge, this measured how hard the object is working. In this case, we have vCenter, and that's taken into account all the rolled up objects. If we change the object that this was looking at, say a particular VM, it would usually reflect things such as CPU usage, for example. The next one is anomalies. Anomalies indicates how the amount of abnormal behavior that is occurring. Very important for discovering if the workload is doing something that it isn't usually doing, and combined with something, for example, high workload, it may be a reason to trigger an alert. Finally, we have faults. Faults list availability and configuration issues based on a known event. For example, possibly a physical host has got a NIC that has lost connection to the physical fabric. In that case, the NIC redundancy error would be triggered. This is an alert that will be generated inside vCenter, and that fault would show up inside vRealize Operations Manager. Moving on to the risk badge. The risk badge again is made up of alert definitions that are configured to impact risks based on alerts and policies that we'll look at later on in this video series. But there are some minor badges that have a strong relationship to the risk badge. These minor badges are, for example, time remaining, which is indicating the number of days before resources are exhausted; capacity remaining, which is measuring the amount of available capacity based on a percentage and based on the total amount of capacity; and finally stress. And stress occurs when an object regularly runs out of resources on a particular schedule, or is regularly pushing some boundaries around CPU, memory, etc., and is indicated on the schedule. Finally, we have the efficiency badge. The efficiency badge is showing us about what possible optimizations we might be able to make in the environment. For example, that includes the badges such as the reclaimable capacity badge, which is looking at oversized or undersized virtual machines, machines that are powered off, and any reclaimable resources that we might be able to get back from the environment. And it's also made up of the density badge, which is where we have set targets of possibly VM to physical host subscription ratios, and it's showing us how we're meeting those targets. Now, as I mentioned earlier, one of the major changes from vRealize Operations Manager 5.x to 6.x is that the major badges no longer have a score. This is because in version 5, the major badges score and color was directly determined by the minor badges that made them up. For example, the health badge would be a combination of high workload and high anomalies, would cause the health to be red or low. In combination, if you also had any faults, the workload badge would then, and the health badge would then go immediately straight to red. Now, in vRealize Operations Manager 6.0, this is no longer the case. The major badges are now actually based on the alert definitions you configure, and they impact the health, risk, and efficiency scores. However, the workload badges and the other minor badges are still important when determining or troubleshooting particular issues within your environment, and we'll now dig into those in the next section. So that brings the section to a close. In this section, we went through how to assist administrators in identifying issues, an overview of the major and minor badges, and some of the high-level changes between vRealize Operations Manager 5.x and vRealize Operations Manager 6.x. Now in the next video, we're going to dive into the health badge and its minor badges in greater detail. Welcome to the next video in the badges series, Understanding the Health Badge. In this video, we're going to take a closer look at the health badge and how it can be used to identify issues at a high level, the workload badge and how it's calculated, the anomalies badge and how it's calculated, and finally the faults badge. So let's start with the health badge. As mentioned earlier, the health badge is where you should start as the first high-level indicator that there might be problems with some elements in your environment or a large amount of your environment. Let's dive into a particular element and have a look at the health badge. So we can see here in this case I've selected a virtual machine, and this virtual machine has got a red health badge, so its health is low. And that's caused by an alert. So it is alerts, as mentioned earlier, it is alerts and symptoms that impact the health, risk and efficiency badges of vRealize Operations Manager. Now there only seems to be one active alert at the moment, so I can select this alert to have a look what's going on. Now in this case, the alert is saying the virtual machine has a high CPU workload, and there's applications that's consuming a high amount of CPU. If we have a look at the symptoms that are causing this issue, we can see that virtual machine CPU demand is at a critical level. In fact, it's at 100%, or it's exceeding 100%. That's because demand can exceed 100%. So we can see here, because it's above 90%, that is therefore a critical alert, and this machine has raised a critical health alert. Now what's interesting in this case in regarding the health badge is that the other minor badges played a significant role as well in terms of determining this alert, or troubleshooting what's going on. We might want to see the timeline or impact or what else was going on in this virtual machine. So without giving a high-level overview of the health badge and how it's driven by alerts, let's now have a look at the minor badges and how they play a role in health. So to do that, let's first select the virtual machine, and then we'll select the Analysis tab. Now straight away, by selecting the Analysis tab, we can see all the minor badges and how they play a role in determining the root cause of an issue. So we have the workload badge, the anomalies badge, faults, capacity remaining, time remaining, stress, and reclaimable capacity density. Now if we have a look at the workload badge varies from object to object. Workload is commonly measured against things like CPU, RAM, disk, and network usage. However, it depends on the context of the object you have selected. For a virtual machine, this could just be CPU and memory. If you're looking at a data store, for example, it would be data store I/O and data store capacity. The idea of the workload badge is to tell you how hard something is working. Now it is possible for the workload badge to be greater than 100%, as demand can be greater than 100% of its currently assigned capacity. If we have a look at this particular virtual machine, the one we're setting the alert on, we can see that the demand is 101% of capacity, and therefore it is flagged as red, indicating that something is wrong. We can see as well that when we have a look at the workload badge, that all the minor badges, especially workload, they take the most constraining resource, and that what determines the workload score. So for example, we can see that workload in this case is made up of CPU, memory, network, and data store. However, it is CPU that is 100%, or the highest in terms of the constraining factors, and that's what the workload score is calculated from. Now let's have a look at the anomalies badge and see how it can affect workloads. The anomalies badge is a measure of how abnormal an object is behaving. The score of the anomalies badge ranges from 0 being good to 100 being bad. Now if we have a look at what anomalies are, anomalies are based on the most powerful feature of vROps, the analytics engine. Analytics allow vRealize operations to understand the normal behavior of any performance metric, no matter the resource or metric type. It is incredibly useful to generate alerts without the need for hard set static thresholds and to assist in the discovery of hidden metric relationships. Anomalies use dynamic thresholds to create upper and lower boundaries for metrics in a particular time period. If a metric leaves this dynamic threshold, it is considered an active anomaly. So if we have a look under the troubleshooting view, we can actually see these anomalies in real time. For example, in this virtual machine with our high CPU, we can have a look in the All Metrics section, and any metric that's currently experiencing an anomaly is shown in yellow, so it's easily to be identified. Now if we bring that metric up on the screen, we can actually see why it's been flagged as an anomaly. The grey band you see before you is the normal range. We can see 0 to 35%. That is the normal CPU usage for this virtual machine. However, the current demand is 101%, and that's considered an anomaly. There are also lots of other metrics that have been triggered an anomaly as a result. Co-stop, demand over capacity, etc., etc. Because of all these certain metrics that have gone outside the dynamic thresholds, our anomaly score has gone up. Earlier on, it would have been close to about 5 or 10, and now it's up to about the score of 21. There's also a noise index in the environment that tells vRealize Operations Manager the average amount of noise that's happening right now in the environment, and anomalies are more triggered as they start to breach above that noise line. So being the noise line would be the 0 mark. Now, as the amount of the anomaly score increases, it hits certain thresholds, being the intermediate, the warning, and the critical threshold. It's as these thresholds are hit, it changes the badge from green to yellow to orange to red. Now finally, we have the faults badge. The faults badge is a measurement of immediate problems that the object has. The score of the faults badge ranges from 0 being good to 100 being bad. The fault badge is mapped against events of an object that could be a loss of a storage path from vCenter server, or a CPU temperature warning, or a DIMM failure, for example. Now in the case of this virtual machine, it doesn't have any known faults at the moment. What we can do is look around the environment to see its peers, its children, or its parent. Now if we have a look at the ESX host, for example, it's its parent, we can see it has some active faults. These are typical faults that you might see within an environment. For example, in this case, we have link state down. So in this case, it's indicating that one of the virtual machine NICs is in a down state. A fault, unlike other badges, has to be a cleared alert. A fault is a one-time event that occurs where workloads and anomalies will clear over time if the symptoms no longer exist. If a fault has been resolved, so in this case, let's say this NIC has been plugged back in and the fault is no longer an issue, we can select the fault and then simply select the Cancel Fault button. That brings us to the end of the Health badge and its associated minor badges. So in summary, the workload determines how hard your object is working right now. The Anomalies badge determines how normal your object is behaving right now. And finally, the Faults badge determines if there's anything wrong with your object right now. In the next video, we'll continue our discovery of the badges by understanding the Major Risk badge and its associated minor badges, the Capacity Remaining badge, the Time Remaining badge, and the Stress badge. In this video, we'll be continuing our journey on badges by understanding the Risk badge. We'll go through the Risk badge overview, then we'll go into the minor badges that are associated with the Risk badge, including the Capacity Remaining badge, the Time Remaining badge, and finally, the Stress badge. Since the Health badge is about looking at the current state of the environment, the Risk badge is about looking at future issues that could become health issues if left untreated. If there are no immediate issues to address from the Health badge, the Risk badge should be looked at next. Now looking on the screen in front of us, we have a virtual machine giving some typical examples of what risk alerts might be. Just like the Health badge, in vRealize Operations Manager 6, all major badges are now derived from alerts and symptom definitions. If we have a look at this particular virtual machine, it has quite a few risk alerts. For example, the virtual machine is projected to run out of disk space, the virtual machine has continuous high memory usage, and continuous high CPU usage. On top of that, we can see the virtual machine is also not in compliance with the vSphere 5.5 hardening guidelines. If we have a look at one of these alerts, for example, we get some information about the symptoms that are making up this alert. So for example, guest free space on particular drive letters is either going up or down, and the time remaining is low. For example, this virtual machine is giving an estimate that within 40 days we'll be out of disk space. So right now this is a risk. In 40 days time, if disk space were to actually hit 0, that would then be a health issue because the machine would stop working. Now let's have a look at the actual minor badges, the Capacity Remaining badge, the Time Remaining badge, and the Stress badge that contribute to the Risk badge and how they're related. Let's start with the Capacity Remaining badge. Just like the other minor badges, it can be found under the Analysis tab of whatever object you have selected. In this case, we have a vSphere cluster selected. Under the Analysis tab, I can select the Capacity Remaining badge. Now, the Capacity Remaining badge shows a percentage of all usable capacity not consumed. Therefore, an object with a score of 100 has 100% of its capacity available for use. An object with a score of 0 would indicate there is no capacity available and therefore would be red. We can see the thresholds that are currently set in the policy at the moment. For example, we are green until we get to 10%, we would be yellow at 5, and 0 would be critical. This particular cluster we're showing 12, so we have 12% of capacity remaining available. It's important to note that capacity remaining is based on the resource that is the most constrained. Different resources have different elements that make up how the capacity remaining is calculated. For example, in this case, we're looking at a vSphere cluster. It's looking at several capacity elements or containers that make up the capacity configuration: CPU, memory, disk space, and then vSphere configuration limits. In this case, for example, we can have a look at CPU. Now, we're only working out the container based on demand. We can see here, based on demand, we have a total capacity of 76 GHz, we have a usable capacity of 69 GHz, and we have remaining capacity of 54% or 37 GHz. What's interesting though, if you look at memory, where we're working on consumed memory, we can see we have a total configured memory of 287 gigabytes, a usable of 258 after we take off 10% free, and we have only 31 gig remaining. Therefore, our remaining percentage in terms of capacity is 12%. Memory is the most constraining resource in this particular configuration, which is how the capacity remaining number or badge is derived. We'll be going more into capacity remaining and capacity management in general in a later section. Now let's move on to the time remaining badge. The time remaining badge is similar to the capacity remaining badge, but instead of giving our score in terms of a percentage of resources that are available, it's giving in terms of a number of days until we run out of capacity. The time remaining score is based on the number of days minus your provisioning time buffer on the current rate of consumption or forecast. The score of the time remaining badge ranges from 0 being bad to 100 being good. And just like the capacity remaining badge, the most restrictive resource will be the one that makes up the time remaining capacity score. One thing that's important to note with the time remaining badge is trending data is taken into account to work out when you'll hit certain limits. Now in this case, as we can see from the capacity remaining below screen previously, we only had 12% of memory capacity. However, based on trending the current provisioning rate and decommissioning rate in terms of a vSphere cluster level, it's actually predicted that even within a year, I won't run out of capacity. If I expand the memory consumed, which was my most constraining metric, we can see that with a 12-week forecast going up to a year, we can see that we'll just hit below the limit. So maybe a year on from now, then we'll start hitting constraint around time remaining. Time remaining importantly takes into account the provisioning buffer, which by default is 30 days. And there's an important reason for doing this. In the case of a vSphere cluster, for example, just because you've got time remaining of 5 days doesn't mean you could procure a new host and put it inside your cluster within that same time period. The provisioning buffer, therefore, should take into account how much time is required to expand that capacity. So in this case, if I was starting to run out of capacity in memory, I would know that I would have to either add memory to my existing ESX host, or I'd have to procure new ESX hosts, rack and stack them in the data center, and add them to the vSphere cluster. If I estimate this takes about 30 days, 30 days is what my provisioning buffer will be set to, and this will impact, therefore, my time remaining score. Now finally, let's have a look at the stress badge. The stress badge is an early warning view of upcoming provisioning needs. An object that is experiencing stress also experiences a high resource utilization over a period of time. The stress score accumulates when the workload exceeds the stress line. The stress score is the percentage of the stress zone area shown in the dark color of the following figure. By default, the stress zone is above 70% observed for any 60-minute peak, then the workload is determined to be in stress. If we have a look down below, we can see a stress breakdown of where the stress period is coming from. So for example, we are receiving stress in both CPU and memory in the case of this workload. However, memory is the most stressed, and therefore that is determining the stress score. If we expand memory, we can see below the total capacity being 4 gig, the peak value 4 gig, and what would be required to set a stress-free value for this workload. In this case, the estimate is 8 gigabytes of memory. So in summary, the risk badge is looking at issues that may occur in the future. And then in terms of the minor badges, the capacity remaining badge determines what percentage of capacity you have left on the object. The time remaining badge determines how long you have left until you're out of resources. And finally, the stress badge, this determines how much pressure a given object is under, whether it demands most or all of its currently assigned resources. Next, in our final video on badges, we'll cover off the efficiency badge and its associated minor badges, reclaimable capacity and density. In this final video in the series of badges, we'll be going through and understanding the efficiency badge. We'll be covering off the efficiency badge overview and its associated minor badges, including the reclaimable capacity badge and the density badge. The efficiency badge is the last major badge, and it shows how efficient we are with our resources in terms of right sizing and target density ratios. Issues related to efficiency are rarely issues that you need to be alerted on, and by default, most alerts are disabled out of the box. However, they're very useful to report on and very useful to act on in terms of getting the most out of your infrastructure. In terms of getting the most out of the efficiency badge, the best way to understand efficiency is to have a look at the associated minor badges, the reclaimable capacity badge, and the density badge. Let's start with the reclaimable capacity badge. The reclaimable capacity badge is a graphical representation of the amount of unused computing resources currently assigned to your virtual machines. In vSphere, reclaimable capacity is only applied to virtual machines, as it's seen that virtual machines do have the ability to be right-sized in quite a straightforward manner. The same could be said for physical hosts, for example, where adding or removing CPU and memory might not be such a straightforward activity. Although reclaimable capacity is only applied to virtual machines, objects such as clusters, hosts, data stores, and other containers still have a badge and associated score due to the relationship and roll-up of all their child objects. Reclaimable capacity has 4 specific items that impact the score. These include oversized virtual machines, idle virtual machines, powered-off virtual machines, and unused file capacity. The first of this is idle virtual machines. Idle virtual machines, exactly as the name suggests, is the number of virtual machines in your environment that are idle. So how is a virtual machine determined to be idle? This is based on the policy settings. So for example, the capacity rules for analysis here on the right say that a flag is idle when a virtual machine is determined to be idle 90% of its time. How a machine is determined to be idle is if the megahertz is less than 100 megahertz, less than 20 IOs of disk, and less than 1 kilobytes of network traffic will determine a virtual machine to be idle. If a virtual machine meets these requirements for 90% of the time, it is determined to be idle and would fall into the list of reclaimable capacity. The next category of reclaimable capacity is powered-off machines. This is by far the most simplest way of determining whether a machine can be reclaimed or not. Powered-off virtual machines follow a similar policy to idle virtual machines, which is they are flagged as a powered-off virtual machine when they've been powered off for more than 90% of the time period. If that's true, these virtual machines are added to the list of powered-off machines, and it's determined that they can be reclaimed and that capacity can be returned. The final type of reclaimable capacity is oversized virtual machines. Oversized VMs will generally be the bulk of the reclaimable capacity in your environment. By default, a virtual machine is flagged to be oversized when the amount of CPU memory or disk space demand is below 50% of selected data range during the time period. A common question that arises with oversized virtual machines is what is the right sizing value based on in the data shown in the VM optimization report. The right sizing recommendations are calculated using demand plus HA plus buffers. Therefore, it is important to consider which buffers are appropriate for your environment to ensure the accuracy of these reports. Now let's move on to the density badge. The density badge score is the ratio of the current density to the calculated ideal density. Ideal density is calculated using the demand that is generated, the amount of virtual capacity that is provisioned, and the amount of actual physical capacity available that is deployed. The goal of density is to calculate the amount of resources that can be provisioned with minimal contention, and therefore you can maximize your return on investment you can receive from your infrastructure. There are 3 parts to density that are calculated. These include the VM to host ratio, the virtual CPU to physical CPU ratio, and the virtual memory to physical memory ratio. The density score ranges from 0 being bad to 100 being good, and the resource type with the highest density score is taken as the bad score. Density is a badge that is useful to understand your workloads at a macro level in terms of what ratios of your environment you're actually achieving. It is also important that the density score of a host or cluster will increase over time, as its capacity remaining score will decrease. So in summary, the reclaimable capacity badge determines which resources you have assigned that are not currently being used or being used very little, and the density score determines how close you are to an ideal density based on all your resources and what is currently being used. With that, we now bring this section to a close. In the section of badges, we covered off what are the major badges, including health, risk and efficiency, what the minor badges are used for, how the major and minor badges are calculated, and finally how policy can affect the scores of both the minor badges and the major badges. In the next section, we're going to take a deeper dive into policies, where we can actually see how you can configure and tune these policies that affects these badges, as well as a wide range of capacity management, alerting, and symptom-based policies. Welcome to the section
Policy. In the previous video, we looked at badges and how they work, what they are within vRealize Operations Manager. In this section, we're going to cover off what roles policy plays within vRealize Operations Manager. In this section, we're going to look at specifically what are policies, where do they fit, what are base override policies, what are the analyst settings within policies, what's the workload automation, metric collection, alert configuration, and applying policies. All these areas are different areas within a single policy that we need to configure, or not configure, as the case may be. The first video is what are policies, and in this video we're going to take a look at what roles policies play within vROps, where they are located, and how to tell what policy is applied to a particular object. So what are policies? Before we dive into that, let's have a look at where they're located within the application. So first off, we log in to our vRealize Operations Manager, and we go to the administration section. On the administration section, it would be the fourth down with policies. Now, we can see straight away that we've got active in a library. So I can see we've got one active here, but you could have many active on different clusters, on different objects. So policies are assigned to groups of objects, they're assigned to a specific object only, they can be assigned globally as a default. So when a new object gets added in, that's what it grabs. We can see here that we've got the D there, which means it's default, which means that everything within this current system will be getting this vSphere solution default policy. Now that specific one has been modified in this instance, but is also one that is created when you first install vRealize Operations Manager. Now we can select this, and we can see the different settings within the policy. We can see how many are locally defined, so set within that policy itself, and we can browse through it all. And we can also have a look at the complete settings, included all the inherited policies and metrics. So you can see there, that's quite a lot that is inherited. And we can have a look at our library. So within here we can create, we can edit, we can set the defaults, we can delete policies, and we can see that there's certain policies that have been updated, and we can also have the hierarchical view of what policies are sitting under other policies. So policies at their core is what drives vRealize Operations Manager. They tell it what metrics to collect, they tell it what thresholds capacity management needs to be, they tell it what analytics capacity management needs to take, it tells it what alerting it should do. It's really everything that vROps is in a nutshell. And we can define these on individual objects. So how do we tell that these policies are applied to an object, or what policy is applied to a particular object? Well, that's quite easy. We can either go into a policy and we can see, I'll choose one that's been applied here, which is our default policy, and I can select related objects. And we can see all the affected objects. It hasn't been assigned to a group, but we can see that it's affected 473 objects down the corner here. Or if we were browsing, so we can go and browse a particular object. I can go to vSphere here. I can select a cluster. Up the top here, that's what policy is applied to that particular cluster. So I can then click on this, and it'll actually take me to that policy. Or doesn't mean other objects will have the same policy. In this case they do, but that's the easiest and quickest way to tell is what a policy is being applied to a particular object you're looking at. Now this is good when you're starting to play with groups and adding different policies to different child objects, making sure that everything's in the right policy. We can see that here. And that's really it for policies and what they are and what role they play. Just to recap, they are the core of vRealize Operations Manager. They drive what metrics are collected, what alerts are enabled or disabled, what symptoms are enabled or disabled, what threshold the badges need to adhere to, how capacity management functions. That's all within the policies, and because we can do it globally at an individual level, it gives a lot of control over what we want to see and what we want to alert on. We don't have to worry about getting garbage alerts from objects we know we're going to get those alerts from. We can set up a custom policy for those objects and go, right, disable these alerts on these because I know they're always going to happen. It gives us the flexibility to be able to do that. In this video, we talked about what policies were and what role they played and what value they add to vRealize Operations Manager. The next video we're going to take a look at is base override policies. This will be going through, starting the configuration of a policy, and this will be the first section of that policy. In the previous video, we learnt about what policies were and what role they played within vRealize Operations Manager. This video is the start of creating a policy, and it's how we select the base and override policies. In this video, we're going to look at what are base policies, what are override policies, and how the inheritance works. Okay, we're going to start the creation of a new policy, and throughout the next few videos, we're going to slowly iterate through the different sections of those policies. Now, the first section that we're going to need to look at is base and override policies. So let's first navigate to our policies section in the administration page. Go to our policy library and click the add new policy. So in this one, we'll just give it a name. Now generally you'd be giving it a name based on what the policy is going to do. It could be CPU ratio for development clusters, for an example. So you can make policies very small and modular, which is the idea, and we'll get into why. So let's give it a name, so I'll just go devel, call it that, give it a description, which is good. I won't do that here to save time. And then we select our base policy. So as we can see this, it gives us a little blurb that the base policy is a starting point. And all the policy settings of that base policy will be inherited. So what that means is that if I change something in the base policy that this policy is based on, this policy will get those changes as well. It'll inherit anything in its hierarchical chain. So what I have here is a very quick view, and we can see here that we've got a base policy up the top. We can inherit down to a dev vCPU ratio policy, which then we can then do a dev cluster 01 policy off. So if I make a change in base policy, both these will get those change, unless we are specifically set whatever setting it is within the policy that'll overwrite any inheritance. So we select our base, and we can see that all the ones that we have there are ready to select. But what I'll select is I'll select my default base policy. Now we move on to, which is very misleading, select base policy, because we've already technically done that. So we look at select base policy. Now we can see here that these are all the different plugins and solutions and adapters that we've added in. And we can have a look at our host system for vCenter adapter. I can click that over there. And what this will show us is that configured in this policy, we've got nothing configured. But inherited, we can see we've got quite a bit that's inherited. So these are all the settings from that default policy, the base policy that we selected. So we can have a look here about that. But then we can select our override settings. So what this is a real quick way to configure policies. So we can have very little policies that only set a couple of things. They might, disable alerting, for example, or they might disable data store alerting, or we don't want to know what our space when it gets down to 10%, we want to sort of cut that out. We can have these small policies that do one thing only. There's only one thing set in it. We can then select any policy that we've decided to have, and I can go, okay, this overcommit CPU and use true memory demand. I can select that and go apply. So what that's going to do is that's automatically going to apply all the settings from that override policy into this new policy we're creating. So we've got another picture here, and we can see I'll select this policy as my base and I inherit that. But these don't inherit, they just override. Meaning that if I make a change, for example in this CPU ratio policy, it's not going to apply to the dev cluster. It's a one-off override. It's an override when we create it or when we want to edit it. So if I applied that change to, in this case here, the vCPU ratio policy, and I wanted to reapply that to this dev cluster policy, then I would have to go in and edit the dev cluster policy and reapply the override for that to work. So we've got our overcommitment there. And that is what base and override policies are. In this video, we learnt about base and override policies. They're the first part of creating a policy that we can apply to an object or objects. And the next video we're going to have a look at is analysis settings within a policy, which is the next section. In the previous video, we had a look at base and override policies and how they worked with inheritance. In this video, we're going to have a look at analysis settings. This is the next section within creating a new policy, and we're going to have a look at object types, what are available, what's unlock and lock mean, and also making changes to specific settings which will impact the analytics that goes on in the background. Okay, analysis settings. So this is the next section in creating a policy, which is step 3. So in here we want to look at what we can change. So within this section is the changes that we make to thresholds and badges, how capacity management works, what is included in stress, workload, what metrics do we want included. So the settings that we make here will change how the analytics engine works and displays our badges and our results in our dashboards based on these objects. So it's quite important. Now we can see here we can go show changes for, and we can select a whole bunch of stuff we've added in with solutions, the base adapters, which are in orange, they're the vCenter ones, and they're the ones that are generally going to be touched on, but others, depending on what they are, definitely can be changed within here. So we can see we can go and select all object types. And what this will actually do is add everything from this object types over on the left over to the right pane. So what I can do is I can actually remove all these, and we can see them disappearing on the right hand side, and I can go, right, I just want to clean that up, I just want to make changes to my cluster. So I can go into here, I can find my cluster compute resource, and I can add that in. So that'll allow me to make changes on my cluster compute resource. I can also add settings for a set of objects, so they're the actual adapters within here, and they'll add it in here too, or I could actually go all objects, and that will actually give me every single one of them, and we can see every single one is now on this side, a whole lot of them. So let's have a look at changing the settings on the right hand pane. So we can notice straight away that some are locked and unlocked, so they're grayed out when they're locked, and they're unlocked, it looks like we can edit them. That's exactly what it is. So if we lock a section, that will actually mean that it's going to inherit what its parent setting was. We don't need to change it, but if it's something you need to change within this policy that's different from its parent policy, or even if you want to override one of the parent policy settings, because this one policy that we're creating right now is specific and needs to overwrite those inherited settings. So we can actually look in here, we can unlock it, and then we can have a look, workload for example. So we can check what resources are included in the workload calculations. By default it's memory and CPU demand, but we can select whatever we want, depending on your environment. We'll leave that as it is. We can have a look at anomalies. So this is really just a threshold. So it allows us to be able to change when our badges turn what color and give alerts and alarms. We can have a look at faults, same thing. So all this one allows you to do is change the threshold score. Capacity remaining and time remaining is a big one and is something that you'll probably spend quite a lot of time in. It's also changing our thresholds, but what it is also is changing our capacity buffers, adding in allocation ratios, 10:1, 6:1, adding in our memory over allocation. I want to allocate 200%, for example. And it also allows us to say, well, I want to include high availability in our calculations. So we'll get more into this in the capacity management side, but this is where the settings are made within this section. As along with all the other badges, as we can see stress, we can change what peaks and windows and exceeds settings. And we can also go right down into reclaimable capacity, what is considered oversized, what is considered idle. So you can see that this is very much affects a lot of things within our settings. It affects what machines are oversized. It affects how much capacity remaining we have, how much time remaining we have. And speaking of time, it also has our time range. So it allows us to say, well, are we going to track usage 24/7? Some businesses need that, but other businesses only need to do during the day, because at night it doesn't matter. So at night you might have backups and other things running, and you don't want that to affect your numbers. So this is where you'd select your time range for that particular policy. So you can have your batch and database servers that are doing their end of month reports and jobs that are running. They can be set to go, okay, well, they're going to be at night time. That's when we want to track them, or we only want to track them 24 hours a day. So you'd select a different policy for them. So the same goes for every single object within this section. We can change the analytics and how it does those analytics from within this section. In this video, we had a look at the analysis settings that we can make within a policy. The next video is on workload automation, which is the next section of creating a policy for your environment. In the previous video, we had a look at analysis settings and how to change them so they impact capacity management or thresholds for badges, etc. In this video, workload automation, we're going to have a look at what is workload automation in a policy, what are balanced workloads, and what are consolidate workloads. Moving on from analysis settings, we have workload automation. So workload automation is very similar to vSphere DRS, which allows vCenter to move resources under contention, or so they can get the resources that they require, using vMotion to go across the hosts. Workload automation is very similar. It does do within a cluster, but it also does across clusters in your environment. So you might have many clusters, and it will make suggestions to move VMs to those clusters. So, like with the other settings, if it's locked, that means that it's getting its settings from its parent. If we unlock, we make the changes. So consolidate workloads basically means use as few hosts as possible. You want to consolidate all your VMs. So maximum will actually do that, and you'll see this picture change on the side, which is really great. It gives a nice detail of what it's actually doing. It's doing maximum consolidation, so it uses fewer clusters as possible. If we move it to moderate, it'll use less clusters when it's practical to do so. So it's not going to try and go out of its way to consolidate. It's only going to consolidate when it makes sense to. And none, which is what most people will probably run, means there's no consolidation. So just use all available clusters that it connects into. Balanced workloads, very similar to how DRS priorities go as well, is we've got our conservative, which means that workloads will only be moved if there's resource contention. Otherwise, we'll just leave it alone. Moderate means that it's going to loosely balance the workload across the clusters. And aggressive means that it's going to try and keep all the clusters as balanced as possible. So this actually means that it might be unnecessarily moving machines, which can have an impact on a move. It means that you're using network. You could have latency. You could have a disruption to the machine, depending. So this one, I wouldn't so much recommend, but I do think moderate or conservative is fine for most environments. And then our advanced settings. So this basically means when moving during balancing, what do we want to prioritize? Do we want to prioritize machines with the highest demand or the lowest? So generally, highest demand would be the recommendation and is the default. But if you want to change that to leave the highest demands alone and just move the low demand ones, then that's fine too. And for workload automation, that's it. In this video, we've had a look at what workload automation is within a policy. The next video, we're going to look at metric collection. How do we disable and enable metrics to be collected within the policy? In the previous video, we looked at workload automation and how to set that within a policy. Now, in this video, metric collection, we'll be having a look at how to enable metrics to be collected, how to disable metrics from collections, and how to search the metrics, as there's quite a lot of them and it's good to know how to get through them quickly. Moving on from workload automation, we have collect metrics and properties. So metrics and properties are what we create our dashboards out of. It's what we create our groups out of. So they're very important. They're what all our solutions are collecting. Now, as we can see here, this is a very small demo environment, and I've got 1,716 pages, or 34,301 metrics and properties that I could disable, enable, configure. There's obviously quite a lot. So when creating your base policy, it's very important that you go through, enough of these to cut out the ones you do and don't want, because every metric collected is obviously space that's going to be using up in your database, as well as bandwidth that's going to be consuming. So it's good to get the base ones set firmly, as in what you want to collect, and then the rest of the policies can inherit that and then just add to it if needed. So as we can see here, it's in alphabetical order. We can see the name, what type it is, metric or a property, the adapter type that it belongs to, the object type, and the state, KPI, and dynamic threshold. So we can actually remove these columns if we don't want them there. But if we want to search a particular endpoint, we can go vCenter adapter and say, I just want the compute cluster resources. So I click that and I only get the compute cluster resources that I want. So then I could go, okay, well, let's search for that. I just want to know CPU, or I just want to know core. You see it limits it down extremely, and then we can choose what we want to collect. So we can see state there is inherited. So this means that it's inherited from the parent, but we could go, I don't want to collect that. I don't want to collect that one either, as an example. And the same goes for both the KPIs and the dynamic thresholds. We can enable them here, or we can disable them, or we can inherit. When adding new endpoints or even supermetrics, you need to make sure that you enable their collection. So we can have a look for any supermetrics I might have, and we can see there that this supermetric that I've created is not being collected. So I want to enable that for collection. If you were just doing this on an existing policy, you'd then make those changes, you'd hit save, and then you'd have to wait 5 minutes for the next collection interval, and your metric should start appearing under that particular object. In this video, we had a look at how we enable and disable metrics and properties to be collected, as well as how we search and efficiently move through those huge amounts of metrics and properties that we can enable or disable. The next video is on alert configuration. In the previous video, metric configurations, we saw how we can enable and disable metrics to be collected by a policy. In this video, alert configuration, it's very much the same except for alerts. So how do we enable and disable alerts for particular policies? Searching alerts, as well as override thresholds, making changes to the alerts without actually changing the alert. Now moving on from our metric configuration, we move into alert and symptom definitions. So these are exactly the same as metric. We're basically saying in this policy which alerts and symptoms do we want to be active within this policy. So any object that it's applied to, these are the alerts and symptoms that are going to be active on that particular object. So for this instance, let's choose one. Our searching and navigating is exactly the same as the metrics. We can either use our filter. Now if your screen resolution isn't big enough, you'll always get the arrows on the side here, and we can go to filter. We can also choose the columns, and I can remove that action or recommendation. So
we get a bit more room. Now, in this instance, let's go host system example, and we can see that these are all the alerts. Now, these could be alerts that we've made. These could be out-of-the-box alerts that come with the installations of solutions. But what we can do here is select if they were not enabled. We could enable them locally on this policy. If they are enabled or inherited, as we can see, inherited with a grey tick means that it's going to get it. We can go, well, no, I don't want this one with battery sensors reporting problems, because I know I've got an issue with batteries and the sensors are not right. I just want to get rid of it for this development or POC using older hardware, for example. So that's the alerts. Now symptoms. We'll get into the differences later in later videos, but symptoms make up alerts, and we can do the exact same thing, search and filter, and I want my hosts as well. Now, what we can do within the symptoms is we can actually change the condition of what activates that symptom. Within this policy, it doesn't actually change the core symptom. All it does is override it for this policy, which means any object it's applied to has that override condition. So we can have a look. Let's look for ones that are normal conditions. There we go. So we can have a look here. We can go, on enable it locally, exactly the same as the alerts. But what I want to do is I want to override. So what I can do is then change that value. So my CPU percentage in this case, and I go, well, no, 90% is too high. I'll move that to 85. Apply, and now our threshold's 85. We can also have a look at this one, the host demand. I was like, yeah, no, I want to know earlier than that for this particular policy, because when I'm going in to create a policy, we have in our mind what it's going to cover. So I go, yep, apply that. Great. Now, not all symptoms can be overridden. So ones that rely on sensors and host data cannot be changed. So if we look for one here, hardware sensor, if I try and override that, it says I can't override this. So that's because there is no override. It's been coming from a sensor. It is what it is. I can't change it. So if I didn't want this particular one, you could just go, no, don't want it. And for symptoms and definitions, that's it. In this video, we had a look at alerts and symptoms, how we can enable, disable them, search, as well as overriding their thresholds for the particular policy. The next video, we're going to take a look at custom profiles and then finally applying the policy to an object or group. In the previous video, we looked at alerts and symptoms and how to enable and disable them as part of the policy that we're creating. In this video, custom profiles and applying policies, we'll be having a look at what are custom profiles and then finally applying the policy to a group or to an object. Now moving on from alerts and symptoms, we move on to custom profiles. So custom profiles are what are used to do capacity and what if statements against. So by default you'll have an average, large, medium and small, but you can create your own, and generally this will be left alone. I don't see too many people change these, but if you wanted this particular policy that we're creating to have a particular sized machine to be computed against, then this is where we would remove those and add another. And then we want to apply the policy. So from within editing a policy, we can choose to add it to a group. So groups are created from using metrics or properties, and they can be, or they can contain VMs, they can contain hosts, they can contain anything that you've got solutions or endpoints to, based on a set of rules, and we want to apply. So we can apply it straight up to any group that we want. So in this case, if I go, okay, well, I want it to run on my vSphere world, or my vcac prod. Let's do that one. We can go save. That will save our policy and then add it to that group. So we'll be able to see all our details, and as we can see there, we've got the relationship there, as that was my base policy. And we can have a look at all the settings that we chose. We can have a look at related objects. So these are my groups, and my affected objects is everything within that group. So 6 objects. Now if I wanted to apply this outside, so I go, okay, I come back in here, I don't want to edit it, I just want to go to groups, I can then add it to a group. Now if we want to have a look at this group now, we go to custom group. Go to a machine within that group, and we can see that we've got our development 1 policy located here. Now if we look back on active policies, we'll see that now we've got priority 1 and a default. So an object can have more than one policy applied, and the priority, whichever has the highest, will be the one that overrides if there's conflicting configurations. And that's it for policies. That's it for the section. In this section we looked at base and override policies and how they affect the policy that we're creating. We checked out analysis settings, how to make changes to badge thresholds. We looked into workload automation and what the different settings in there mean. We set up what metrics we wanted to collect or not to collect as part of the policy. We also configured what alerts we wanted to be active or not active as part of the policy. We looked into custom profiles and what they are, as well as applying this particular policy to groups and then verifying that that group and the members of it had the policy. The next section is on capacity management, where you'll spend a lot more time in policies around the capacity management side.
Welcome to this section, capacity management. In this section, we'll take a look at what are resource containers and how do they apply to capacity management, the different consumption models in vRealize Operations Manager, including demand, allocation, and consumed, overcommitment and how to apply overcommitment, and then projects as well as pipeline management. In this section, we're going to dive into resource containers and how they apply to capacity management. We'll go into what are resource containers, what is the difference between observed and configured metrics in regards to capacity management, and finally some policy or best practice recommendations for capacity management in your own environment. One of the first decisions that need to be made in relation to capacity management is what containers are going to be selected. A resource container is a set of metrics for an object type that gives capacity data for one particular aspect of an object. The resource containers for a resource are usually quite predictable and are defined in the capacity/time remaining section of the vROps policy. Solution provider will use metrics that would commonly come from capacity management within that field. In vSphere, for example, the most common options for containers are objects such as CPU, memory, network, disk I/O, disk space, and so on. Although administrators cannot define what metrics are used for resource containers or define their own resource containers, they can select which resource containers are used to determine capacity remaining. There are 2 important points we need to take out of this. The first is that for each object type, different containers will apply. For example, what we're looking at here is a vSphere cluster. We can see, for example, that we have CPU, memory, data store I/O, disk space. We can see on the right which capacity containers are selected. Different objects will have different containers applying to them, even though all objects can have a capacity remaining badge. For example, a data store might only have data disk space remaining, data store I/O, etc. The second important point to take into account here is that we should only take into account containers that we want for that particular object based on our capacity management policies. So for example, what we mentioned in the previous chapter is that the capacity remaining badge takes the most constraining resource to determine its score. If you look below, I've got a score of 13% for capacity remaining because I have 13% remaining capacity. We can see from the metrics below, this is determined by memory. It's rounding up roughly 13% of memory available. Now we can see on the right, I can choose which containers I enable and disable to determine that factor. If we expand memory as well, we'll actually see there's different types of memory consumption models: demand, consumed, allocation. We'll dive into that in the next video. It's an important aspect though to consider what containers you might want to enable and disable based on your environment. For example, in this case, I have disk space enabled as a container. Now, it's not the most constraining container in my use case, with 52% remaining. However, for many customers, LUNs are presented or provisioned as the environment grows on demand. vSphere isn't across this, so it might say if you've got disk space enabled, for example, that's commonly the most constraining factor. If we're looking at this example, which is a vSphere cluster, commonly the most things that people would be concerned about would be CPU and memory in terms of modeling capacity remaining. vSphere configuration limits are also another common one, and possibly if we have an environment that is maybe constrained by network I/O or disk I/O, those metrics might also be included as well. Another important factor to consider when choosing a resource container should be where the supporting data comes from and how it originates. In other words, how vROps calculates that data. With vSphere data, each container's total capacity is either configured or observed. We can see for a CPU example, it states that it's configured, where if we look at data store I/O, it's observed. It would be the same, for example, for network I/O. Configured total capacity is a hard factual piece of data that vROps has access to or is able to directly derive from other data. A good example of this would be the cluster CPU or memory information. Through vCenter, vROps knows exactly how much gigahertz and gigabytes of memory each ESX host has. Therefore, this is quite a factual number and it's quite a well-known limit. Conversely, observed total capacity is a value that vROps has had to estimate based on historical maximums observed. A good example of this would be data store I/O or network I/O. If we take data store I/O for example, there is no way for vROps to know exactly what the maximum I/O of a data store is when very little is known about the underlying storage. Even if vROps did have a detailed understanding of the underlying disk pools and RAID groups for example, there are just too many variables in the equation to give a definitive maximum. This doesn't mean that containers that are using observed metrics should be ignored or not be used at all, but it's something to consider when comparing metrics across different containers. One thing to keep in mind as well, that configured metrics are generally quite static over time. For example, unless we add or remove a host, it's unlikely these will change. However, observed metrics or observed capacity can change over time. If vROps, for example, sees a vSphere cluster is able to push more network bandwidth through or is able to do more I/O across all its data stores, the total capacity could increase or decrease over time. Now, before we end this video, let's go through some high-level policy recommendations around containers, specifically for vSphere clusters. vSphere clusters are the most common object that people are applying capacity management to in the vSphere world. And what we'll do is a quick high-level overview of some of the recommendations that we generally make around these containers. The first is CPU. If we take the most common constraining factors in a vSphere cluster environment, CPU and memory would be right up the top. Therefore, we recommend that CPU would be an enabled container that you would consider for policy. We'll dive into in the next section the differences between demand, allocation, and consumed. In a similar fashion, memory. Memory is one of the most common constraining factors in capacity management for vSphere clusters, and it's very common that it will be enabled. Now that we've discussed CPU and memory containers, let's discuss the network I/O containers. The network I/O containers are commonly disabled due to some of the drawbacks that we discussed earlier around observed containers. It is also common with network I/O that other third-party solution packs would be used to look at physical network utilization. It is also rare that network I/O is a constraining factor in most environments since the common introduction of 10 gigabit networking. Similar to network I/O, data store I/O is commonly disabled due to the constraints of observed containers. However, unlike network I/O, data store I/O and storage performance in general is a highly important area of capacity management for virtualized environments. As such, it is recommended that an administrator keeps their eye on performance capacity in their storage environment, and this is commonly provided by third-party vendor-provided solution packs. That now leaves the final two areas, vSphere configuration limits and disk space. vSphere configuration limits are commonly left enabled, simply because these are configuration limits that are recommended to never be exceeded by VMware, and the limits are generally so high that it's rarely a constraining factor. That simply leaves disk space. Disk space is a situational capacity container, and should be enabled in some situations and not others. In situations where storage is pre-provisioned, so for example you're either using a vSAN environment, or all the storage from array has been pre-provisioned to an environment, disk space can be a very powerful factor in determining how much capacity is left in your environment, and allows vROps to be a single pane of glass for compute, memory, and storage. However, in the case where storage is provisioned on demand, for example, as a vSphere cluster nears its capacity limit in terms of storage, new LUNs are carved off from the array, it is recommended that this be disabled, and this feature be provided by a third-party solution pack. That now brings this section to a close on containers. In the next video, we'll go through the different consumption models, and how they affect the remaining capacity on various containers. In the next video of the capacity management series, we'll cover consumption models. In this video, we'll go through how different consumption models affect capacity management, what are the differences between the demand, the allocation, and the consumed consumption models, and best practices and recommendations for which consumption models to use in which situations. Now, in the last video, we discussed the importance of containers. Now it's time to discuss an equally important topic, which is the consumption models. The consumption models, which include demand, allocation, and consumed, are different methods for calculating capacity in containers and are set in the same location as enabling the containers themselves in the policy section, which is shown here on the right. Before we dive into the specifics on consumption models across different containers, at a high level, you can think of demand and consumed as how much a resource is actually being used on the infrastructure, where allocation is how much a resource has been configured on an object. If both demand and allocation are enabled on a container, it results in two different calculations being performed on the resource. And just like in overall capacity, the most constraining result will be used. Therefore, it is important to understand where these calculations are derived from to ensure that the capacity estimates match your real-world environment. To explain the differences between the different consumption models, we'll go through the two main areas in which they apply, which is CPU and memory at a vSphere cluster level. Let's first have a look at CPU demand. We'll talk about how it's derived, and as well as any recommendations around it. CPU demand is a derived metric made up of multiple sub-metrics. These include metrics such as CPU usage, CPU ready, and so on. They're used to estimate the amount of CPU an object actually wants to consume. Although demand and usage are often identical, it is possible demand to exceed usage, and this would indicate resource contention. Demand is a useful way to manage capacity with, as virtual machines will rarely use all the CPU that has been configured with. This is the basic principle of overcommitment. You'll also find that demand usually matches the usage percentage metric that is observed in the vSphere web client. As a general recommendation, because CPU demand accurately reflects the amount of CPU that a workload in your environment is requesting, regardless of what has been allocated, we recommend enabling this container in nearly all situations. That brings us along to CPU allocation. From a host or cluster perspective, CPU allocation is the ratio of virtual machine CPUs, or vCPUs, to physical ESX host cores, or pCPUs. Ignoring buffers and overcommitment, as we'll discuss this in a later video, CPU allocation allows an administrator to manage capacities simply based on this 1-to-X mapping. Using CPU allocation as a capacity container is usually based on environment design or special use cases. For example, if an administrator has a cluster dedicated to mission-critical applications, and there was an associated organizational policy that CPU overcommitment should not exceed 2-to-1 vCPUs, for example, then an administrator could use the allocation model in combination with the overcommitment to ensure that this ratio was never breached. In terms of an overall recommendation, as a general rule, for production server clusters, it is recommended that you either disable this container altogether, or that you ensure that you have an overcommitment ratio high enough so that this container does not unnecessarily become the most constraining resource. Now let's discuss memory. If we look at the capacity containers to consider for memory, we've got memory allocated, memory consumed, and memory demand. And they're all measuring slightly different things that need to be taken into account. Memory allocation works very similar to CPU allocation and is quite straightforward. We're simply adding up the total sum of all the virtual machines on the ESX host in the case of a cluster and how much memory they have allocated to them. This works quite well from a conservative point of view, as we can ensure, for example, that we have every single piece of memory accounted for that could possibly be used. However, from a capacity management point of view, it doesn't actually necessarily reflect how much memory is being used on the host. On the other side of the scale, we have the demand metric. The demand metric is quite complicated and is relatively using memory demand, which is derived from the active memory metric. The active memory metric can vary in terms of its accuracy, and is sometimes quite misunderstood in how it's actually calculated. The demand metric generally reflects how much memory the workload needs if it is right-sized. However, in many workloads and many environments, right-sizing may not be an option. That leaves us with the consumed metric. The consumed metric is a new metric for memory utilization that was introduced in vRealize Operations Manager 6.1. To best see the use case of consumed memory, let's have a look at an individual ESX host. If we have a look at an individual ESX host, under the workload miner badge, we can see the memory consumed section below. This gives us a good overview about what consumed memory actually is, and as we can see, it's made up of a few different things. In the top section here, we have the memory demand of all the virtual machines. They're split up by virtual machine on the bottom row here. You can see here that some machines are taking up 100 meg of RAM, 500 meg of RAM, in this case 5 gig. But we also have this grey area, and this is the memory overhead. In this case, this particular host, which has 32 gig of RAM, almost half the memory is consumed by overheads. In this case, it's the memory allocated to vSphere. Memory consumed is probably the most accurate metric to use, because it takes into account the memory that the workloads are actually using, which might include, for example, transparent page sharing, and it also takes into account memory overheads on the ESX host. As a general recommendation, we'd recommend that memory consumed will be the most conservative metric to use and applicable to the most widest range of use cases. In the next video, we'll discuss overcommitment, such as CPU and memory overcommitment, and how these apply to containers and consumption models, as well as how we account for peaks in capacity management. In this video, under capacity management, we're discussing how to set and the benefits of overcommitment. In this video, we'll take a closer look at how we set overcommitment in vRealize Operations Manager policies, the difference between CPU, memory, and disk overcommitment, how we account for peaks, and overcommitment recommendations for general policies. Overcommitment is a basic principle and benefit of virtualization, and it plays an important role in capacity planning. As discussed, for demand and allocation, overcommitment is only applicable to the allocation model, and allows either a percentage or a ratio of overcommitment to be set for CPU, memory, and disk space. As we see in the policy section below, if I select CPU demand as an enabled container, in consumption model I can set the overcommitment ratio. For example, 8:1. So in this case, I'm setting a target of capacity management for 8 vCPUs to every physical CPU. If I go to disk space allocation, for example, I could also set that I want to over-allocate my disk space by a certain percentage. This can also be set here. Now, let's go back to the actual capacity remaining tab and have a look at the different effects of CPU memory and disk overcommitment. As discussed in the previous video, CPU overcommitment allows a ratio or percentage of CPU overcommitment to be set, thus affecting the amount of total capacity available for the capacity calculations. As we can see above, the CPU overcommitment has been set at a ratio of 8:1. If we have a look at the underlying resources that are underpinning this cluster, the total amount of PCBs in this cluster total 22. However, when we times that by an overcommitment ratio of 8:1, we have a total capacity available of 176 vCPUs. When using the CPU allocation model, it is generally the case that some level of CPU overcommitment should be set. If you do not have a specific level of CPU overcommitment in mind for a certain environment, then this can often be set at a fairly aggressive level, such as 6:1 or even 8:1. Let's move on to memory overcommitment. Memory overcommitment is relatively straightforward, since the introduction of large pages and other factors that affect transparent page sharing. Memory overcommitment is built on the age-old vSphere principle that due to VMs not requiring all the memory that they have been configured with, as well as leveraging transparent page sharing to share common memory blocks, we can overcommit memory on a host or cluster relatively safely. However, unless inter-VM TPS is re-enabled and large pages are disabled, which is commonly done on dev test environments or VD environments, memory overcommitment should generally be set to 0. In most circumstances as well, it's simply a more conservative and cautious approach to not use memory allocation as a container and simply use the memory consume model instead. Finally, that leaves disk space overcommitment. Disk space overcommitment is relevant if you're using vSphere thin provisioning, otherwise known as thin VMDKs, on VMFS data stores. This allows administrators to set target overcommitment percentage on storage to benefit from thin provisioning. This percentage should be based on an organizational policy and should be in line with the associated risk of overcommitted storage. Containers, consumption models, and overcommitment now covered. It's time to move on to the relatively simpler, but just as important topic, which is peak consideration. Peak consideration is set in the vROps policy and is a simple checkbox. There are brackets that indicate here that it may result in higher write size, but it also has a dramatic consideration on capacity management. Let's apply this setting and have a look at the impact it makes. If we go back to our cluster now, we'll see the capacity remaining figure has changed considerably. In our case, the memory usage has gone up, and it's still the most constraining resource, but we now have 0% remaining. Peak consideration was originally introduced in vROps 5.6, and it allows the stress metric to be used to account for capacity spikes and peaks. The use of this setting has two main effects. Virtual machine demand is now based on peak demand rather than average demand, and right-sizing recommendations are also based on peak demand rather than average demand. The first key takeaway here is that this setting only affects demand and consumption. The allocation model is unaffected. Therefore, this setting is most relevant to CPU demand, as this is most often the most constraining resource, and right-sizing recommendations for both CPU and memory. The second key takeaway here is that it changes the way demand is calculated, and therefore the remaining capacity in the calculation. As you can see, now that I've enabled stress and peaks into account, my consumed memory has increased in terms of my peak value is now taken into account, and therefore my remaining capacity has decreased. As an overall recommendation, at the end of the day, the use of peaks and consideration of the option comes down to your environment and your requirements for your environment. For mission-critical and production-type workloads, this setting should generally be enabled to ensure a conservative capacity management model that caters for peak workload. For dev test environments or VDI environments, however, you may choose to disable this setting and simply work off the average workload for capacity demand. Although this may sound like you are setting yourself up for failure, remember that not all workloads peak at the same time, and in certain environments, consolidation and cost may be more important than guaranteed performance. In the next video, we'll finish the last of the vRealize Operations Manager policy settings around capacity management in relation to high availability and buffers. In this video under Capacity Management, we're going to take a look at buffers, which is the last section of policy options for vRealize Operations Manager. In this video, we'll go through showing the effect and importance of usable capacity, how we can enable vSphere HA to be taken into account as a buffer, as well as the effect and use cases around other buffers for capacity management, and finally some recommendations and use cases that might apply to your environment. One of the great features about vRealize Operations Manager is that under capacity management, we can take into account buffers such as vSphere HA and other buffers. If we have a look at the vSphere Web Client, for example, we can see the current cluster memory usage in a cluster. However, this is a poor way to determine how much available capacity we have. One thing that people often forget to take into account is they may have vSphere HA enabled, but if they were to lose a host or multiple hosts, do they have enough capacity remaining in the cluster to handle all the workloads running at their optimum capacity? If we have a look at vRealize Operations Manager, there are settings to take this into account. First of all, there are capacity rules and policy assigned to configure this, which we'll go through in just a minute, and there's also a buffers section. The buffers in vSphere HA essentially remove capacity from the total capacity and then give a more realistic idea of how much remaining capacity you have. This can be figured quite simply under the default section policy. For example, if we select the policy that's active on the cluster or item at the time, we can edit the policy, then under the capacity and time remaining section, we've got two different options. We've got buffers, which is set on each individual container and consumption model. And then we also have additional settings that affect capacity and time remaining calculations. The first one is high availability. As a general rule of thumb, if you have vSphere HA enabled on your clusters, you should probably have this option enabled from a capacity management point of view. As mentioned earlier, this is an important practice to ensure that administrators don't over-provision clusters. vSphere has features such as admission control, but these only guarantee resource reservations. They don't take into account general cluster over-provisioning and the effect of what if a host were to fail if reservations weren't in place. In a similar thread, we also have buffers. Buffers apply after vSphere HA, and they're just as important to ensure that clusters aren't over-provisioned. It is very rare that an administrator would want a cluster running at 100% CPU utilization and 100% memory utilization. Buffers ensure that there is slight overhead taken into account to ensure this doesn't occur. On things that are relatively static, such as memory, a relatively small buffer can be given. So for example, if we're using the different memory models, probably a 10% buffer would be sufficient. In regards to CPU, however, it can depend on the type of workload. If you're doing relatively static workloads like batch workloads, this could be set at maybe 20% or 25%. However, for more interactive workloads, you might want to increase this to say 30% to take into account severe peaks. Now that we've applied our buffers in our policy, both vSphere HA and standard buffers, we can see the effect it has on the usable capacity inside the capacity remaining tab. If we expand CPU, for example, and we look at demand, we can see we have a total raw capacity of 76 GHz. However, after a buffer of 30%, that leaves us with a usable capacity of 53 GHz. It's this that we then work out our peak value and our demand on, which determines our remaining capacity. In almost all circumstances, it's highly recommended that either at a minimum vSphere HA be taken into account, but also on top of that, a general buffer minimum of 10% should generally be applied in most use cases. Now in the next and final video under the Capacity Management series, we'll be going into the new and exciting feature of projects and pipeline management with vRealize Operations Manager. In this final video under Capacity Management, we're going to look through the exciting feature of projects and pipeline management. In this video, we're going to take a look at how projects can assist in workload planning, workload pipeline management, and the difference between planned and committed projects. Projects are a new feature of vRealize Operations Manager 6.0 that replaced the old what-if functionality from vROps 5.x. A project is an upcoming change to your environment that affects either the supply or demand, or both, of capacity. Projects allow capacity modeling to help an administrator set up a hypothetical scenarios, such as adding or removing virtual machines or adding or removing hosts from a cluster. These scenarios can then be used to determine how a pipeline of incoming organizational projects will affect the time remaining calculation. Now let's walk through some examples about how we can set up these scenarios. So first, to explain what we have here on the screen. The Projects tab is simply another tab under a selected object. It is very useful for modeling future demand. If we have a look, there's a few basic things that we might need set up to model our workloads as they come in. The first is the capacity container. By default, it chooses the most constrained resource, which is probably the resource you want to model. Different environments will have different constraining factors. Certainly memory would be one of the most common. In my case, I'm using the most constrained resource, which happens to be memory consumed. Now, without any pipelines dragged onto the canvas, I can see here with my current modeling, if we take today's date and look forward to the 12th of December, I just start to hit 100% capacity by the end of the year. However, what we can do now is create and drop some projects onto the pipeline to see what their effect will have. When creating a project, we simply hit the plus button down the bottom left. Give the project a name, say new web server. Then we decide whether its status is going to affect planned or it's going to be committed. You can change a project from planned to committed at any time. And what that means is it will affect the badges, the capacity remaining badge and the time remaining badge. So a planned project won't affect those badges, it's more of information only, where if it's committed, it will. Once we've set the planned or committed status, we then add a scenario. Having a look at the scenarios on the left, we have different types of scenarios we can add. For example, we can add capacity based on a percentage of capacity, an actual ESX host or a data store. We can change capacity in terms of a percentage. We can remove capacity based on a host or object or data store or percentage. Or we can do the same things with demand. So at a high level, adding and removing capacity would generally affect adding and removing ESX hosts, or possibly changing the configuration of existing ESX hosts. For example, maybe adding more memory to existing physical hosts. Adding demand is certainly one of the most common scenarios used, such as adding a percentage of demand, maybe with 10% or 20% growth over time, or adding an individual virtual machine. Let's take the virtual machine scenario. We can drag as many scenarios as we want onto an individual project, and we can also have multiple projects dragged onto the canvas. So maybe our scenario is add web server. Now, when we're modeling adding a virtual machine, for example, we can say how many machines, or maybe there's 2 in this case. We can either specify how much memory, CPU and disk space the workloads will consume manually, or we can simply populate the metrics from either a profile, such as the average virtual machine profile, or possibly we might want to say pick an existing machine. Maybe we have an existing web server in our environment that we can model these from, and that's what we'll choose to model the virtual machine on. In this case, I'll pick an existing machine and simply search from the list. Once that's done, the last thing to do in this case will be to pick an implementation date. Maybe we can estimate that we'll be adding this server, say 1 week from now. Then finally we can save and close the project. Now once that's been done, we can then now add projects onto the canvas that are shown at the bottom of the screen. So down the bottom of the screen, we have our projects. Now I've had some that I created earlier. For example, one of the projects I have here is that maybe I've got a new mail system, some new exchange servers that I want to model. I simply hit the plus button, this will be added to the taskbar, and this will be modeled on the forecast. Now currently we're running out of capacity in the end of December. Now with this new workload coming in 31st October, we can see we're actually hitting 100% capacity around mid-November. Now, at the same time, we can do some other modeling. So, for example, that was a change of demand. What about a change of capacity? So, knowing that we were going to run out of capacity mid-November, we said, well, what if we purchase another ESX host, added it to our cluster? Let's model the impact of that on the environment. So I can add that as another project. So in this case, I'll add another vSphere host. If we do that before that event was to occur, we can see here that we're no longer out of capacity. In fact, by the end of the year, we're still under 75% capacity. Even if we add on our other projects, such as an additional vROps node, an additional web server that we're just catered for, we can see even with that additional demand, we're now no longer going over capacity. We can show this as a combined effect, which is where we've got combined projects, or we can put them in separate, compare the sort of a what-if scenario, compare these different projects. Overall, a very powerful feature in terms of pipeline modeling for upcoming workloads. It's also a common use case to use this feature to model what is the right ratio of CPU and memory to have in your ESX hosts. We can have a look at the different containers, such as memory demand, memory consumed, memory allocation. At the same time, we can look at CPU demand. Then we can simply model, adding capacity, certain amount of CPU or certain amount of RAM, to find that right balance to get the most out of our hardware. That now brings this section on capacity management to a close. In the videos in this section, we covered off the idea of setting the right containers and how important it is to set the right containers for the right use cases, the different consumption models and how they're used in different situations, such as consumed, allocated, and demand, knowing how and why to set certain overcommitment values and in what use cases they're important, the simplicity and importance of setting buffers such as HA, CPU, and memory buffers, and finally we went through pipelines and project management, and how it's a valuable feature in future workload planning.